gentlemen, good morning. My name is Marian. Welcome to Ocean Challenge 2022. The opening ceremony will begin in 2 minutes.
Hello everyone, we are Emily from National Taiwan Ocean University. Our proposal is to solve the problem between cultural festival and environmental pollution. Philam Goes Festival!
We are 2022 Ocean Challenge team from Changjiang Christian University. This project uses micro and man-vehicle modules combined with the environment education to improve the situation of the pollution within the marine, from the foam floating equipment, polypropylene.
Together
We can make
a difference. Follow
the passion.
Together we can.
We are terrestrial animals to the sea. Our proposal is Oyster solution to marine debris by combining an artificial reef and new oyster bed. We hope to protect marine resources and the environment by brainstorming and to create a cleaner marine.
We come from
diverse, unique,
but all hold
the shared duty
to make the marine ecosystem clean again.
That's what we fight for.
and
Era go!
We are the Ocean Advocates for Young Minds team.
Our team integrates the dynamic simulation of marine debris in environmental education. We hope that the project can raise young learners' environmental awareness and practice it in their life.
Again,
we're the Ocean Advocates for Young Minds. Education and ocean awareness redefined.
We are the Ocean Saviors from Taipei Fuxing Private School, and we are introducing our original design, oil packaging apparatus.
we hope to ultimately create a cleaner ocean.
FIPA! Doris! Shan! Thank you everyone!
Hello, we are FGC, which stand for Fiona, Grace, Simba, Evan, and Abraham.
Protecting the ocean is everyone's responsibility. Hello everyone.
We are the terminator of marine discarded waste mass. We are the students from Kaohsiung Ruixiang High School.
We're the student ambassadors from Kaohsiung Senior High School, due to the extreme climate changes occurring in our planet these days. And our goal is to make a more environmentally friendly planet.
Our proposed plan, built around the core values of educating and raising awareness in this modern age.
This is Team Eco Beach. Through our plan, we hope to improve the preservation of Taiwan's coral reefs.
This is a pleasure and honor to be participating in this challenge, Ocean Challenge 2022.
A technology can bring ocean back to the azure. agile fighter, from pollution to solution. We want to brew and we make it come true.
Our proposal is detection, orientation, and removal of derelict oyster cores at Western Taiwan. We aim to develop an underwater system to detect those wastes, and we will use an innovative tool to remove those wastes, which has never been used in Taiwan for clean ocean.
Name's Kemno. I'm a leader of the sea, and our teams have 4 members. They are Kim Hui, Winan, and Minh Châu.
Our team will talk about the current environment. Currently, the environment is threatened by heavy pollution, which is largely man-made.
There are thousands of sea creatures that are being displaced because of the garbage.
That's why we wanted to give you some ideas to contribute to a better environment.
We are Herald of Ocean. We are from Hong High School.
We hope that our idea can contribute a part to protect the ocean.
Please join us to protect our oceans.
The ocean is being increasingly contaminated.
We can change the situation if we work together.
And we are oceans there.
Ni hao Taiwan. We are the young spirited conservationists served behind from University Malaysia Terengganu. Our motto is Ocean of Discoveries for Global Sustainability.
Good morning, ladies and gentlemen. Welcome to Ocean Challenge 2022. My name is Marian, and I'm your moderator today. Thank you for joining us today. Ocean Challenge is an annual STEM competition co-hosted by the American Institute in Taiwan and the Ocean Affairs Council that seeks to encourage and empower the young generations to get involved in addressing some of the most challenging issues facing our ocean. Today, we are so delighted to have NASA satellite oceanographer Dr. Jeremy Wardell as our keynote speaker, and also to have Taiwan's youth representative of the Ocean Conference 2022, Mr. Huai-Pu Chen, sharing his experience at OOC with us. We're also very excited to have 19 finalist teams with us to present their innovative proposals, and I'm sure it's going to be a blast. Now I would like to invite Director Alkirk of the American Institute in Taiwan to deliver her opening remarks. Please welcome Director Alkirk.
Deputy Minister Tsai, Dr. Wardell, distinguished guests and judges, student participants, good morning. 大家好. I am delighted to be here today at the launch of the 4th Ocean Challenge event, a joint effort between the American Institute in Taiwan and the Ocean Affairs Council. I would like to thank the OAC for their continued partnership and support for this important youth-focused endeavor. As a result of this close partnership, the Ocean Challenge event has grown and expanded each year. AIT will continue to work with the OAC to support events that help us achieve our common goals on environmental protection. This event is particularly important to me because I was born and raised in Tampa, Florida, a part of the United States where the ocean is an important part of everyday life. My mother is a retired biology teacher, and I cannot count the number of times my family accompanied her to Audubon Society bird counts, beach cleanup events, or efforts to uproot invasive species. These experiences have given me a lifelong awareness of the beauties of nature and the importance of protecting and conserving our natural world. The purpose of the Ocean Challenge is to raise awareness among youth of the critical issues confronting our oceans. We want to inspire the next generation to think constructively about these serious and complex problems. By doing this, the Ocean Challenge allows us to leverage one of Taiwan's greatest resources, its talented, innovative youth. Our first Ocean Challenge included only high school teams from southern Taiwan. In subsequent years, the event expanded into a broader contest, open to high school, college, and young adult teams. This year is particularly exciting as we welcome for the first time international teams from high schools in the Indo-Pacific region. I look forward to seeing how this event continues to develop in the future. The United States and Taiwan share many common goals and values, including our shared desire to preserve our planet for future generations by reducing harmful emissions and conserving our natural resources. Our oceans are some of the world's most important natural resources, and protecting them is critical to ensuring a sustainable future. The climate crisis is an ocean crisis. We must combat greenhouse gas emissions and their impact, including ocean warming, sea level rise, and ocean acidification through decisive collective action. Protecting our oceans and supporting ocean communities requires partners from both the public and private sectors to work together to create innovative solutions. The United States is a committed champion of ambitious global targets for ocean conservation because a healthy ocean benefits people and nature alike. To the students participating in this year's competition, I want to say thank you. Thank you for your enthusiasm and your willingness to get involved. I hope your participation in the Ocean Challenge has sparked even greater interest in the environment and in our collective stewardship of this planet. I encourage all of you to continue applying your creativity to solving some of the greatest challenges that confront mankind. Thank you. 谢谢大家.
Thank you, Director Alkert. Now, with much honor, I would like to invite Dr. Qing Biao-Tsai, the Deputy Minister of the Ocean Affairs Council, to say a few words with us. Please welcome Deputy Minister Tsai.
AIT Director Alkert, AITK Branch Chief Mr. Yu, Dr. Wardell, honorable guests, judges, and all participants, good morning. I'm delighted to be here to welcome you to this year's Ocean Challenge. And I'm especially excited to have around 100 finalist team members of the Ocean Challenge 2022 here with us today. The United Nations 2022 report of the Secretary General on Oceans and the Law of the Sea points out the alarming status of the world's oceans. Actions on various fronts need to be taken to restore the health and the resilience of the marine environment, mitigate and adapt to the impact of climate change, protect and preserve marine ecosystems, and sustainably use their resources. That's why the upcoming 2022 UN conference to support the implementation of Sustainable Development Goal 14 is dedicated to scaling up ocean action based on science and innovation, seeking to improve the state of ocean science and bring to the fore science-based and innovative solutions for sustainable oceans. The Ocean Challenge event is a program aligned with the core of UN's SDG 14 that aims to raise the young generation's awareness of the ocean degradation, mobilize them to take action, and encourage them to come up with innovative solutions to ocean issues that use marine science as the key element. Over the past few years, this event has engaged and inspired many students and youth to think critically about these serious and complex problems facing our oceans, and offer them a platform to learn from each other's perspectives and ideas. Despite the impact of COVID-19, I'm pleased to see the Ocean Challenge event continue to grow with each year. What has been a nationwide student event has expanded into an international competition that will also include participation from young professional and international student teams for the first time this year. Among these participants are leading representatives from civil society organizations, emerging professionals studying in ocean-related graduate programs, as well as enthusiastic and talented high school students hailing from 10 countries with the motivation to protect our oceans. I would like to express my appreciation to AITK for inviting prestigious ocean experts as keynote speakers to the Ocean Challenge event over the past few years. This year, we are honored to have Dr. Jeremy Woodale as our keynote speaker. Dr. Woodale is an oceanographer at NASA Goddard Space Flight Center, where he also served as the project scientist for the upcoming PACE mission. I can say for sure that his speech will broaden our horizons and inspire us with insightful perspectives. As there are many innovative teams vying for a limited amount of finalist slots, 19 finalists have been selected to progress to the final presentation round. This year's competition saw each team developing an innovative science-focused solution idea that could make a difference in the ocean issues, such as identifying pollution in our oceans by developing innovative AI monitoring techniques and robotic technologies, improving the efficiency of the oil spill response by designing an oil packaging apparatus, among others. This year also marks the first time a new award has been announced when Best Proposal Award was added to the awards slate. The winner will have the opportunity to receive a grant of up to $100,000 NT to implement their proposal idea. The award will be bestowed on one outstanding team that best innovatively uses science as a strategic asset to support and solve ocean challenges. We hope this newly announced award will increase an even greater sense of achievement of the participants, and the OASIS funding is being invested in this creative use further effort to implement their initiatives. A special thank you goes to our judging panel. Thank you for taking time off your busy schedules. And I want to thank our Ocean Challenge partner, AITK, and everyone on my team who worked so hard to make this event happen. I wish this year's Ocean Challenge event the greatest success. You all have a productive two-day forum ahead. Thank you.
Thank you, Deputy Minister Tsai. All right, so thank you, Deputy Minister Tsai. Now I would like to invite everyone to take a screenshot together. All the distinguished guests and participants, please turn on your camera and no need to turn on your microphone. And please look at your webcam at your big smile. 现在我们要来进行大合照，那么我们也要请各位贵宾还有与会者要开启你的摄影机。而且呢，请您看向您的镜头，那也不用开麦克风哦。那and three things I would like to ask you to do. So first of all, please wave at your camera. So could you now please wave at your camera now? And please do remember to turn on your camera, so because we are going to do a screenshot together. Yes? Okay, so wave at your camera now. Okay. Now the next, please give a thumb up like this. Yes. Is it all done it? Good. Okay. Last thing, please show your victory sign like this. Yeah. Okay. Good. So great. 请问导播，这样的照片是否这样子是足够的？我们是不是已经完成了这个团体的照片了？
Okay, thank you.
Oh, good. How great. So we have done our group screenshot. Oh, now I see everyone. Thank you. So, sure. Are you sure that we all take our screenshot all together now? Yes?
Yes,
Good.
I'm sure.
All right.
Thank you.
Good. Thank you. So before we proceed the next section, please turn off your camera and enjoy the rest of today's program. Thank you. We will now move on to our keynote speech section. We're delighted to invite Dr. Jeremy Wardell as our keynote speaker this year. Dr. Wardell is an oceanographer in the Ocean Ecology Laboratory at NASA Goddard Space Flight Center, where he also served as the project scientist for the upcoming PACE project. He will give a talk on observing the microscopic living and non-living ocean from space, followed by a live Q&A. Dr. Wardell will join us online today. If you have questions for him, please submit your questions via the chat feature in the lower right of the meeting window. We will hold the questions until the end of the speech and then read questions for Dr. Wardell to answer. So now please join me without further ado. Let's welcome Dr. Wardell.
Hello, everybody. Thank you so much for the invitation to speak at the Taiwan International Ocean Youth Forum's Ocean Challenge 2022. I'm really honored to be here. My name is Jeremy Wardell, and I'm a satellite oceanographer at NASA's Goddard Space Flight Center in Greenbelt, Maryland, in the United States. My presentation today focuses on phytoplankton. These are microscopic aquatic algae and bacteria that play similar roles to land plants. Specifically, I'll discuss how we observe the microscopic living and non-living ocean from space. I'll open by reviewing why study phytoplankton at all, but then we'll get to the fun stuff. Why is NASA involved? How do we use satellites to observe microscopic species? What are the challenges we face? And I'll conclude by trying to demystify the use of satellite data, or flipped on its head, to encourage the use of satellite data for these kinds of studies. It's not that scary. So why study phytoplankton at all? Let's have some fun. I'm going to ask you two questions. Do you like breathing? Do you like eating? If you answered yes to either, then you care about phytoplankton. Despite comprising less than 1% of all plant and algal biomass on Earth, phytoplankton are responsible for roughly half of the oxygen that we breathe, and they represent the first link in the marine food web while playing key roles in all parts of the ecology of the ecosystem. As you can see on the left, they come in all different shapes and sizes, and they have different nutritional values, they sink at different rates, and they play completely different roles in the ecosystem. But at a fundamental level, they're photosynthesizers just like land plants. So here's a fun fact, another one. Despite being so diverse and smaller than you can see with your naked eye, phytoplankton convert roughly 100 million tons of carbon dioxide to organic matter each day. This translates to 40 billion tons, or roughly 40 petagrams of carbon every year. It's a huge amount. And because of this, over 99% of all organic carbon on Earth resides in marine sediments. So clearly, phytoplankton play a major role in Earth's carbon budget. And you're probably familiar with various versions of these graphs where you're looking at carbon dioxide levels in the atmosphere over geologic timescales with an emphasis on the last 150 years in the rapid climb. Well, there are both sources or emissions of carbon dioxide that allow this accumulation, but there are also sinks, or things that pull carbon dioxide out of the atmosphere, like land plants and phytoplankton. And I want to draw your attention to the figure on the lower left-hand side. You'll see in the different colors that the atmosphere, land, and ocean are represented by different widths of their sinks. And what's important to take away here is not only that the ocean is a consistent sink for carbon dioxide, but in many cases, it is a greater sink than land plants. So clearly, our global ocean is critical in regulating Earth's climate budget. Now, up to this point in the story, we've only talked about beneficial phytoplankton, but there are a number of harmful or nuisance species as well. Here's two examples of horror stories. The first is a harmful cyanobacteria, and on the right-hand side, you're looking at a satellite image of Lake Erie, which is one of the Great Lakes in North America. And all the greens you see indicate the presence of harmful cyanobacteria. Now look all the way at the left. That structure you see is the water crib in Lake Erie, or the water intake plant for the city of Toledo in Cleveland, Ohio, in the United States. This is drinking water, cooking water, showering water. It has harmful cyanobacteria in it at certain times of the year. This is a big problem. And it's not just limited to these kinds of nuisances. They can also offer fish mortalities. And here's an example of a news article from Oman, where an algae outbreak suffocated thousands of sardines. So the theme of the next section of this talk is from microscopes to telescopes, telescopes that orbit 700 kilometers above us. How do we measure phytoplankton? Well, traditionally, this is done in a boat at sea collecting water, where you'd use a net or some kind of filtering apparatus to collect a sample, and then you would look at it under a microscope. Of course, we've evolved since then to more sophisticated methods, ranging from radiometric systems to spectrophotometers, high-performance liquid chromatography, imaging systems, and so forth. But as you can see, the ocean can be difficult, and collecting water isn't always easy. To complicate things further, Earth is really big, at least on the scale of trying to see all of it from a boat, and the ocean covers 71% of the surface. So let's take a moment and zoom away from the Baltimore, Maryland area where I'm speaking to you from and get a sense of how big the ocean really is. You can see Chesapeake Bay, most of the North Atlantic Ocean now, North America, and now the full globe. That is a lot of surface area to cover on a boat, especially if you want to do it routinely. So this is where NASA comes in and where satellite technology can help us. So I mentioned quickly Chesapeake Bay, and what you're looking at on the left is a map of Chesapeake Bay with 49 stations in blue dots. There's an excellent program here, and I'm sure that they exist all over the world, where there's been routine data collection since 1984. They go out monthly or a little bit more often, they visit all 49 stations, and they collect 19 different hydrographic measurements, inclusive of algal biomass, water clarity, and dissolved oxygen. But those dots are a lot bigger than the actual parcel of water you actually see. So despite the fantastic data set that has been collected here, there is still so much missing in space and time. And it takes a couple of days even to get to these 49 stations. So things can change as you visit one place to the other. This is one view of Chesapeake Bay, synoptic, from one NASA satellite known as MODIS Aqua. You can see the entire bay in the blink of an eye. Now, I don't want to oversell this, because there are also days in the Chesapeake Bay that look like this, where you're getting nothing at all. But my larger point is that satellites can be used to complement in situ sampling with routine, synoptic, and consistent views of our critical marine ecosystems. These are two technologies that play very, very well together. Next, I'd like to introduce the concept of ocean color. The color of the ocean or atmosphere, or really anything, is determined by the interaction of incident light with substances or particles present in the water or atmosphere or whatever you're looking at. In this case, we're passive remote sensing, and that means that we are using the sun as our source of light. So in this case, you have photons coming from the sun of all different colors. They make their way through the atmosphere, and if they're so lucky to not get redirected or absorbed, then they reach the ocean surface. They penetrate the ocean surface. Well, that's where our fun begins as ocean scientists. Now, I should say that a photon has two fates in anything that it's passing through. It can either be scattered or redirected into another direction, or it can be absorbed. And the scattering and absorption properties vary by wavelength. That is, they vary by color. And so in this case, you can see that the magnitudes of the various colors are changing within the water column. Now, some of these photons are lucky enough to be redirected back out of the water column, which is what gives the water its color. They make their way back through the atmosphere and into the field of view of the instrument. And that, in a nutshell, is how this whole system works. The core satellite data are really just accurate measurements of light intensity at different wavelengths, from the ultraviolet all the way into the shortwave infrared. Let's introduce that concept one more time, and maybe a little slower. What gives the ocean its color? Well, sunshine is white. If the ocean absorbed all of the sunlight, it would appear as a black ocean. If the ocean reflected all of the sunlight, it would appear as a white ocean. Now, water molecules themselves absorb red light. So if there's nothing in the ocean but water molecules, the ocean appears very, very blue, almost purple. And I have colleagues that have traveled to the South Pacific Gyre, way open ocean, and said that the water actually looks almost purple there. There's nothing in it at all. So here's an example that might hit closer to home of how red light behaves in water. What we're looking at is a squirrelfish, red colored by nature with big eyes. This is what it would look like when it's pretty shallow. As it gets a little bit deeper, you can see the red turns to gray, the way we perceive it. And then when it decides to hide in a cave, it's almost black. And this is not because the fish is changing colors, it's because there's no more red light to be observed down in that cave. So back to our example. Again, water molecules absorb red light. Ocean will look blue with nothing in it. But there's usually something in it. And again, we're going to bring this back to phytoplankton. Phytoplankton absorb blue light. And with a small amount of phytoplankton, the ocean still appears blue. With a large amount of phytoplankton, the ocean appears green. Large phytoplankton and sediments can also reflect light back out of the water. What this really means is that in the open ocean, where you're far away from, say, riverine influences that can introduce suspended sediments, or in places where something is being deposited into the ocean from the air, the color of the water is entirely driven by the abundance and type of phytoplankton in the water. So again, where do the satellites come in here? Well, they're designed to measure distinct wavelengths of light. And if you do that, and you do that well, then you can relate the magnitudes and intensities of the different colors of light to the geophysical properties of interest. Here's a more detailed example. In this case, we're looking at the northern part of the Gulf of Mexico, just south of Mississippi in the United States. If you look at those red boxes going from the top to the bottom, you can see by eye that the variations in color of the water are fairly pronounced, from brown to blue. If you look on the right, that is a spectral interpretation of what the color of the ocean looks like, and it mimics what the satellite would see. So the x-axis spans from the blue on the left to the green on the red. And you can see at the bottom, where the water is appearing blue, the magnitude is much, much higher in the blue than it is in the red. Whereas if you go all the way to the brown at the very, very top, you can see the blue light is mostly gone. There's more red light because of scatterers in the water, but predominantly you get the greens and yellows that are leaving with the brown. So visually, you have some sense of what's in the water just based by looking at the color. Now that the satellite has measured it, we can invert these different spectra into concentrations of what we search for. So this plot is very, very simple. On the x-axis, it's just a ratio of a blue radiance and a green radiance. And on the y-axis, it's the concentration of chlorophyll A, which is a photosynthetic pigment that's ubiquitous. It's found in all phytoplankton and land plants. And what you can see here is that this ratio varies with the chlorophyll A concentration. So by measuring an optical property, the intensity of light from space, we have a very simple but elegant tool to relate optics and color to an actual concentration of something on the ground. And then once you've done that, coming back to my home in Chesapeake Bay, you can create these satellite maps of these concentrations. And in this case, the northern part of the bay where you see the reds and the oranges, it's very, very high concentrations. As you go to the right side of that image where you get into the blues and the purples, the concentrations are much, much lower. Okay, so let's have a little bit more fun and build on this a little bit. Here's a series of panels that represent different products we can derive from ocean color radiometry. For your reference, in the upper left-hand corner is the same chlorophyll map I showed you on the previous slide. The other 4 panels are other products. Working from left to right, you can see a map of particle backscattering. This provides an index of sediment load in the water. Next, you see diffuse light attenuation. This is basically a metric of light penetration. How clear is the water? So water clarity and turbidity can be inferred from this. Then you have dissolved organic matter absorption. The reason I mentioned that this is useful for runoff is that in most cases, especially estuarian systems, dissolved organic matter is coming from rivers on land. And so if you start measuring the distributions in the more open waters, you can start inferring whether it's a very wet season or a very dry season where the rivers are flooding into the system. And then on the far right, you can see red light reflectance. And this is just simply the magnitude of the scatterers in the red part of the spectrum where we know water isn't absorbing all of the light. And that is another indicator of sediment load. Now, of course, we can go way beyond this, and the promise of some of our new missions is to go far, far beyond this. Really, as we've mentioned before, the reason for being for many of our new missions is to drive into phytoplankton community composition, including the harmful ones. And then there are other things that are of a lot of interest too, like particle size distributions, which can tell you what's in the water column, and then, of course, carbon budgets and light budgets, which all will help get closure in land, ocean, atmosphere carbon budgets for the full Earth system. Here's where we are today. And to me, this is one of the NASA accomplishments that actually rivals the moon landing. I'm sure others would disagree, but I find this to be a remarkable accomplishment. What you're seeing here is a 2.5-minute video, and we won't watch it all. But in that 2.5 minutes, you are looking at 20 years of biological change on Earth. And so in this case, just envision that your senses on Earth have been transported into space and you are watching Earth breathe. And I think really that's what it's doing here. So there's some obvious changes that you might recognize. You can see white ice retreating in the northern hemisphere during warmer months and coming down to the south and cooler months. You can see on land the deserts in brown and the forests in green and how they are evolving with season. But you can also see the forests of the ocean. Now this color bar needs a little bit of an explanation. It's the same one we looked at before, but in this case, when you're looking at the deserts in the ocean, they're in the purples and blues. And when we're looking at the forests of the ocean, they're in the greens, yellows, and reds. And if you're looking, for example, in the northern hemisphere, say near Alaska or Greenland, you can see that every spring the forests appear. And then they recede in the winter. If you look really, really carefully, you can see that the patterns are changing. If you look, say, for example, in the South Pacific Ocean at the big purple blob there, if you watch this long enough, you'll see that it's expanding in time. And that is a result of Earth's changing climate. You can also see the big bright reds show up in certain places more intensely. Now imagine trying to do this from a boat. It's just not possible. We've talked in generalities so far about the science of ocean color and what can it provide, but we haven't spent any time yet on the instrumentation. And the takeaway message from this section of the talk as we lead into the challenges portion is that each satellite instrument and each mission really offers different capabilities. And you're going to need to think about which instruments you want to use for whatever it is you want to study, because those choices matter. And I'm illustrating this using a Landsat image of the east coast of Queensland, Australia. where you can see you have a very bright land relative to a dark ocean, some image artifacts. There are some spectral groups that appear in different places. Some are in big bunches, some are filamentous. Lots going on in here. Deep water, shallow water, bright water, dark water. Your instrument choice is going to influence your ability to deal with these different things, because the instruments come in all shapes and sizes. Some of them have small spatial footprints, but low temporal repeatability. Landsat here, for example, sees a 30-meter footprint, but only sees the same partial of water every 16 days or so. Whereas an instrument like the NASA MODIS instrument has a 1-kilometer footprint, but can see the entire globe every 1 or 2 days. There's a lot of choices we're going to have to make, and we'll dive into a bunch of these as challenges in a forthcoming section of this talk. What I really want to make here is that this is a consumer's market. We're fortunate enough to have a lot of different choices. Now, this is a bit of an eye chart, and I wouldn't wish on anybody to have to read this quickly while I'm talking, but I wanted to give you a sense of how many different instruments and how many different countries are invested in making ocean color successful. And what I want to draw to your attention are the columns in the light blue box named swath, spatial resolution bands, and spectral coverage. And this is where I want to reinforce that there are a lot of choices to be made here. Some have very narrow swaths and fine spatial resolution and only a couple of bands. Others are wide swaths, coarser resolution up to 1 kilometer or more, but far more bands, different kinds of spectral coverages, and so forth. So, file that away as we move forward and you move forward and you're thinking about how you might use satellite data. So one of the cool things I get to do at NASA Goddard Space Flight Center is serve as the chief scientist for a new ocean color and atmosphere mission known as PACE, Plankton Aerosol Cloud Ocean Ecosystem. I'm bringing this up because it offered me a great opportunity to really understand the challenges in ocean color remote sensing and to force some thought on what needs to be done in the future to overcome the number of obstacles that we face so far. So let's talk about those next. If you're interested in learning more about PACE, it's very easy to find online, and the website is listed in the upper right-hand corner. There are 4 challenges that I'd like to present and discuss today: atmosphere correction, sun glint, image artifacts, and spectral resolution. All but sun glint are things that I mentioned very quickly before, so we'll take a deeper dive in the next couple of slides. Sun glint is important too, and I hope you will find it to be as fascinating a problem to overcome as I do. Let's start with atmosphere correction, and to do so, we're going to go one more time in a little bit more detail on the steps for deriving ocean color data products from space. So if you're looking at this cartoon, I want you to see that the satellite is viewing the spectral light field at the top of the atmosphere. In other words, it's measuring all the colors that we care about, but the color is related to not just what's leaving the ocean's surface, but everything that's in the atmosphere too, whether it's an atmospheric aerosol, such as dust or soot, or even just marine sea salt, air molecules itself, and then of course clouds. And then there's reflection of light off the sea surface and so forth. The process of removing that atmospheric signature we refer to as atmospheric correction. And again, this is just removing the atmosphere from the total signal that the satellite measures to derive an estimate of the light field that is just from the sea surface. Now, the second step of this is what we've discussed already. That is taking that water leaving signal and relating it to something we actually care about, like a chlorophyll A concentration. And then something we're not going to discuss today, but is also really interesting, is what you do with it after you have this beautiful measurement. How do you map it? How do you bin it up into space and time? It really depends on the project you're pursuing. Back to number 1. The reason that this is a challenge is that the signal we measure at top of the atmosphere is roughly 90% atmosphere and 10% ocean. So as oceanographers, we're throwing away most of our signal. And I'm showing that in 2 examples here. The x-axis is 400 nanometers to 900, so think of this as blue on the left to red on the right. And then the y-axis is just the magnitude of the radiant signal. The blue lines represent the very, very blue open ocean, and the red line is Chesapeake Bay, so think of it as a very brown, turbid environment. Now look at the LW with the arrow pointed to it in the bottom there. You can see that after atmospheric correction, the signal we're actually looking at is less than 10% of the total signal measured by the satellite. So we have to spend a lot of our time not just doing cool oceanography, but interacting with atmospheric scientists to best understand how to get rid of the signal they care much about. And here's just an example of a complicated one. This is the north coast of Libya. And not only is it a semi-cloudy scene with some aerosols in it, but you can also see two different dust plumes. The plumes are different colors. Some of the dust is above the cloud deck. Some of it is below the cloud deck. The contrasts are different. The optical properties are different. There's a lot of work to be done here. So very challenging. We've been very, very successful in the open ocean. We're gaining a lot of momentum in doing this well along the coastline. And I think the next frontier, in case any of you are interested, is doing this even better in inland water systems. Now, I mentioned sun glint and my fascination with it. We cannot see ocean colors through sun glint. If you've ever stood at the shore looking into a sunset, or you have been on an airplane looking out at the window towards the sun, you will notice that all you're seeing is bright sunlight, no color at all. The satellite can't see it either. This is how it manifests in a satellite image, where you can see right through the center of it, there is this big swath of bright light that we just are not great at removing yet. And so this is data that's lost unless we do something about it. So how does a true ocean color sensor combat this? You tilt the instrument. You tilt it fore and aft. Let me dive into that a little bit more. All right, so here are two sample orbits from an instrument that is tilted 20 degrees on the top and not tilted at all, but looking straight down, nadir viewing on the bottom. And anything you can see in the dark blues or oranges and reds there is the area of that swath that is unavailable for ocean color because it's contaminated by sun glint. And as you can see, that pattern, that oval shape, gets much, much smaller when you have a 20-degree tilt. And now we're looking at some real data here. We're looking at two different instruments, CWIFS, which on the left, which tilts, and MODIS Aqua, which does not tilt on the right. Now you can see that they have different orbital patterns, but these were collected on exactly the same day. And what I want you to take away is that the pattern of data lost, which is shown in black, ovals in the middle, is much, much bigger for MODIS Aqua, the system that does not tilt. Now, one interesting feature in the CWIS image is the horizontal dark patch that goes right through its oval in the center. That is where the instrument tilted from fore to aft. So you lose a little bit of data there too, but you're recovering far, far more. Now, if we're looking at this on big global scales, what are the real losses due to sun glint? It's one thing to say you're losing something in a singular swath, but how does that all add up? What I really want to point out is this bottom number here. So in this case, this is the total data loss if you didn't tilt your instrument relative to one that tilted fore and aft in, say, 30 seconds or so. Now forget that for a second. Just think about this number. It's 17 million kilometers. And all of those numbers are pretty big numbers. We're talking about tens of millions of kilometers. For context, 17 million kilometers is roughly the size of South America. Now, what I didn't tell you is that these statistics were calculated for 2 days worth of global coverage. So think about that for a second. If you don't tilt your instrument, you are potentially losing an area of the ocean the size of South America every 2 days. Now, as you might imagine, this also happens at the equator for the most part. Now start thinking about what happens at the equator and start thinking about El Niños and things like that. You're blind to a lot of the phenomena here. And yet, not all instrument systems tilt. In fact, MODIS and VIIRS, which are two NASA instruments, do not. PACE will tilt, but it's presented a huge engineering challenge to get a tilt system system that's reliable to last 3 to 10 years, pushing something back and forth that's 300 kilograms, which is why it's a fascinating challenge. So moving on to our third challenge, I mentioned instrument artifacts and how that relates to instrument designs. Well, broadly speaking, there are two kinds of radiometric instruments that you can choose from. The first is a rotating telescope, where you have a camera that spins perpendicular to the direction of flight. And usually that has just a few, if not one, science detector. The other one is a push broom. Push broom operates a lot like your cell phone camera in the fact that it has millions of pixels that each operate differently. So in the example I'm showing here with CWIFS, which is a rotating telescope on the left, you have one single science detector, and if you look at exactly the same image from MARIS, which is a push broom on the right, you have multiple science detectors. And you can see that the multiple science detectors, the push broom, the image quality is nowhere near as good in the sense that you can see a diagonal seam where there are two different camera systems that need to be used to get a wide swath. You can see a ton of speckling. Well, you might ask yourself, why would anybody pick a push broom then? Well, the real answer is back to the trade with spatial footprint. The nice thing about push broom systems is they can collect a lot of photons, which means you can often have smaller science pixels on the order of 30 meters like you have for Landsat to 300 that you have for MARIS. When you have a rotating telescope and you're not dwelling and staring at your target all the time because you're spinning, well, you're collecting far fewer photons. And that means to collect enough photons to actually have a meaningful signal, you have to be looking at a bigger area. And so what you gain with an instrument like CWIFS is very clean image quality, but at the expense of larger science pixels. Whereas where you have a push broom like MARIS, you have small science pixels, but your image quality is usually not as good. And this multiple detector problem is pervasive through all instruments that have multiple detectors in ocean color imagery. And really the problem becomes you have just more detectors to calibrate, and it's very, very difficult. So for the HICO image on the top, you can see a lot of striping. You can see very organized striping in VIIRS on the bottom. Now VIIRS is an interesting one because it is a rotating telescope, but instead of having a single science pixel, it has multiple science pixels, and those are manifesting into those very organized stripes that you see in the image. So again, there's no right or wrong answer here, but given the consumer's market that exists, you, the consumer, as you're trying to save the world, and I applaud that, have to start thinking about what kind of instrument are you actually going to be using. Our last challenge relates to the move from multispectral radiometry to spectroscopy. Now, to this point, we've talked about the need to measure colors of the rainbow, but we haven't talked about how many and which ones we're actually measuring today. Left-hand side here shows 3 heritage superstar NASA missions, CZCS, CWIS, MODIS, and VIIRS. And what it's intended to represent is the position and color of the wavelengths they measure. And you'll notice the number, at least in the visible, ranges from 4 to 7 or 8 or so. Those were intelligently and strategically placed to target a lot of biogeochemical variables that we want to consider. And we've been very successful for several decades here. But you'll notice there's a lot of gaps, and a lot of the nuances we're looking for geophysically fall into those spaces in between. And that's where my mission, PACE, comes in. We will be NASA's first global hyperspectral mission using spectroscopy. So instead of multispectral, hyperspectral, a continuum of color from the ultraviolet all the way into the shortwave infrared. There will be no gaps. If you're asking yourself, why does this matter? You've been successful for 40 years. Why take on this additional challenge? Let's pursue a quick case study. And this case study is in the northern Arabian Sea. Now, during its most productive seasons, the phytoplankton class of diatoms typically dominates. And that's shown in the gray image in the middle. And that feeds a typical system of zooplankton eating phytoplankton, fish eating zooplankton, and on and on and on. Noctiluca, over the past 20 years, has become a nuisance invader, and it has started to outcompete diatoms, meaning that it's taking over. So the diatom community is diminishing, and the Noctiluca dinoflagellate is actually starting to become the dominant species during the productive season. And this is causing a lot of problems there. And so monitoring it is critical. But the Arabian Sea is huge. So again, doing this from a ship-based system is a huge task, which is where satellites come in. But remember, the signals from the ocean are small, and differentiating between them requires a lot of information relative to what we have today. And so what you're looking on the x-axis here is the 5-wavelength system from VIIRS. And the black represents the signal from the diatoms, the fish food, and the red indicates the changing ecosystem that favors salps and turtles, Noctiluca. And what I want you to notice is right around 550, a green band. It's the only place we can tell these two apart. Whereas if you look below that at the PACE instrument, you can see by measuring the continuum of colors, you're seeing much more obvious differences in those spectra. And those differences are what are going to allow us for the first time to start teasing apart different phytoplankton communities from a global satellite system. This is really, really exciting. Now imagine transporting this to the region that you are most interested in, where there are harmful algal blooms, or you have fisheries that you want to monitor, but you know they are changing. This is like putting glasses on. So the move to spectroscopy is really, really important. So I know that I'm throwing a lot at you, and we've started from some very simple topics into some very difficult challenges associated with remote sensing. And I know that can be daunting. A little bit like drinking from a fire hose. It's a lot to ingest. So in my last 2 minutes or so, just want to spend some time talking about how I can encourage you that using these satellite data really aren't as complicated as you think. First off, we try to put as many resources to make this user-friendly and approachable as possible online. This is a quick example of the PACE website, which I've already mentioned, and it has exhaustive lists of the data products that we will produce, how they're produced, why they're produced. It has technical documents if you want to dive deep into the weeds and go down rabbit holes to learn how the technology works. And it also has the fun stuff, a lot of outreach material, a lot of quizzes and things you can do to learn more about phytoplankton, and a pretty comprehensive social media presence as well. And when you're ready, searching for and downloading satellite data for ocean color isn't nearly as complicated as you would think. At the Ocean Color website listed here, it's effectively one-stop shopping. My group offers VIIRS, MODIS, and eventually PACE data all from this site. You can view data before you download it. You can download by region. You can download by time. It is fairly straightforward to use, and it's very, very powerful. Once you dive into it and you start having questions, we have a very active and welcoming online forum community. It has somewhere between 2,000 and 3,000 different members, all of whom are eager to help answer questions. We can help point you in the right direction to get the answers you seek, but it's a very, very nice resource, particularly for newer users. Once you get to that point, you might be asking yourself, well, I don't even know how to begin analyzing or even viewing the data, and that's where CDES comes in. This is an open source visualization and processing software package that allows you to look at data, perform rudimentary data analyses to it, and also use processing code that is identical to what we're using at NASA. Everything is open source. You can exactly reproduce everything that we're putting on the streets here. And if you visit the CDES website, you'll find a ton of different resources that relate to users' guides, YouTube tutorials, videos, and presentations that teach you how to do things. And every once in a while at a community meeting, we'll have classes on this as well. And then finally, I want to point out that citizen science is playing a wonderfully emergent role in ocean color and atmospheric science too. I have 3 examples here. The first is a grassroots organization that has actually included members of the government in Maryland, wading out to the water once a year for decades and monitoring water quality, relating that to a satellite product. The U.S. Environmental Protection Agency works with our group to develop a mobile app that can be used to monitor water quality in U.S. inland lakes. And then organizations all over the place, including this example from the University of Maine in the United States, have apps that are very low cost or free that allow you to make measurements of water quality and start contributing to larger data sets that are immensely meaningful for furthering our field. Well, if you made it this far, I appreciate you hanging in there with me. I know that was a lot, but I hope you found it energizing or intriguing or mind-bending, at least, that we can use an instrument orbiting 700 kilometers above us to better understand how our ocean is changing, both on regional and global scales. And at the end of the day, this kind of science is just beautiful to behold. In many ways, it's artwork, which is why I will leave you with this comparison of the Northern Arabian Sea with a Van Gogh painting. Thank you so much for your time. Again, it has been an absolute pleasure to be invited to this, and I look forward to your questions.
Thank you, Dr. Wardell, for your insightful presentation. Now it's time for the Q&A. We would like to invite AIT Kaohsiung's Deputy Branch Chief, Mr. Lambert, to moderate the Q&A section, and Dr. Wardell will answer all questions. Please welcome Mr. Lambert and Dr. Wardell.
Hello. Dr. Wardell, can you hear us okay?
I can hear you beautifully. Can you hear me okay?
We can. Thank you very much for your great presentation. So everybody, my name is Jack Lambert from the American Institute in Taiwan Kaohsiung branch office. It's a pleasure to be here today to moderate this question and answer session. Now, unfortunately, we only have about 10 minutes for Q&A, so we'll get through as many questions as we can. And I also want to apologize in advance. For those of you that submitted questions, I do not have the tones for your names, so I apologize if I mispronounce. And for our friends from Vietnam, I speak Vietnamese with a northern dialect, so I apologize to our friends in the South if I don't pronounce your name right. But our first question is from Abraham Shu from the Morrison Academy Kaohsiung. And her question is, Abraham's question is it possible to use a similar technology in order to detect the amount of plastics in a certain place with the change in colors through satellite detection? Also, does the existence of plastics affect the accuracy of this technology? So Dr. Wardell, over to you.
All right, that is a very insightful question, and it's really timely. In fact, I just returned from a symposium where there was a session dedicated just to that. The short answer is that we think we can do this, but we're not sure yet. And the problems that we have are that the microplastics are very, very small. They're distributed throughout the water column horizontally and vertically, and most of them eventually get bleached by the sunlight, and so they offer very, very little change in color. But general progress has been that some of our shortwave infrared wavelengths can actually start to see these. So it is a stay tuned kind of answer. We cannot do it today, but we're moving towards a place where we think we can do this, and it will get into the challenges again in the trades related to, do you want to use a satellite with a big footprint that's super capable, a less capable small footprint satellite, because these patches, especially the Pacific patches, can be absolutely enormous, but again, the plastics are very small. Right now, we do not believe that the signal is strong enough to contaminate what we're looking at today, though.
All right, thank you very much. And the second question is from Monique Mercado from the National Sun Yat-sen University. Her question is, there are a lot of satellites deployed by NASA, but I'm wondering, what are the differences among those? How can we access NASA data? Is it free and open for everyone?
Good question. Yes, there are a number of satellites that NASA and our international partners all have, and they all vary. And you might have seen this in one of the charts after you asked the question, where they come in different shapes and sizes. And so the primary differences that you want to pay attention to are, for whatever science question you're asking, what are the number of wavelengths and what range do they span, from the ultraviolet to the shortwave infrared? What is the temporal repeatability? Some of the big satellites with huge spatial pixels will see the globe every day. The smaller satellites where you want to get down to 10 or 30 meters on the ground, the trait is that they only see that same location in space every 16 days. And then, of course, whether you have a phenomenon you're looking for that's either small or large will depend too. So really, it depends. What you choose in instrumentation depends on the science question that you have. NASA does have a data policy where everything is free and open access. So depending on the instrument, you will be able to acquire data free, no charge, available to the public on a time scale from 3 hours to a couple of days from actual collection on orbit.
Great. All right, for our third question, we've got Van Xiang from Nguyen Hue Hoan High School in Vietnam. And this question is, for a satellite to orbit the Earth, it has to go very fast. Now, does it take accurate measurements at those high speeds?
That's a cool question. Yes, it does. There's been a lot of effort to get technology that, spectrographs and file readers and so forth that can operate very, very fast. So this kind of touches on the difference between multiple technologies, whether you have a rotating telescope or a push probe. I mean, the fundamental thing that we do from orbit is just collect photons, as many photons as you can. So if you're staring at Earth, even though you're traveling very fast, you're high enough in altitude that you can collect enough photons to make a meaningful measurement. But that gets into whether you're always staring versus you're spinning, where your duty cycle is much, much smaller than the other type of technology. So short answer is yes, we can do this very, very accurately, but it takes a whole village to develop the technology to collect all these photons and push them through the system very, very, very quickly. It is why your cell phone in many ways is more powerful than some of these satellite instruments. And it's not because the satellites are amazing, it's just that your cell phone won't survive a space-like environment. And so there's a lot of testing that needs to go into taking today's technology and getting it super durable and hard. So not only can it live in outer space, but launch is a remarkably difficult environment with acoustics and vibration, and things break all the time. So excellent question. That was fun.
All right. So our next question is from, okay, we did that one. So next one is from Lin Yushan from FIPA. And Ms. Lin asked, can this detection technology be, I guess the satellite detection technology, be input or used with drones? And also, are there any temperature or distance restrictions for this method to work?
Very insightful question. Yes. In fact, there's a big push to take these radiometer systems and maintain them on drones or autonomous underway vehicles, aircraft. I mean, in principle, the satellite technology was born from an instrument that was flying on an aircraft. So it is not something that was developed just for space. It was actually ported to space from aircraft. But that was in the 70s, so there were no drones. Now the big push is to miniaturize everything. And that could be done for a CubeSat environment where your entire satellite is the size of, say, a shoebox, or something that could fly on a quadcopter. And there's so much power in being able to do this, because you can take a much, much deeper look at small areas of interest. Temperature is usually not a problem with temperature, and we spend a lot of time in the laboratory, whether it's for a drone or for a satellite instrument, understanding instrument behavior with temperature. Distance. So distance with drones, of course, is battery life and so forth. But it does touch on another interesting part of this whole process, is distance from land. And depending on how big your footprint is, you have very bright land or very bright clouds next to a very, very dark ocean. And your instrument to measure the ocean signal has to be able to recover very quickly from seeing a bunch of bright light into looking for a very dark signal. So, imagine kind of tilting your head towards the sun and your eyes lose focus for a few seconds. The instruments do the same thing. So in that sense, there are some distance requirements that we need to pay attention to.
All right, and I think this is going to be our last question. We'll get another one from one of our international participants. This is from Amanda Fika Kanchan from the University of Malaysia, and is it Terengganu? I apologize if I didn't pronounce that correctly. Amanda asks, how frequently is data from NASA satellites collected and recorded to determine data accuracy about phytoplankton distribution?
Great. So from space, it depends on the instrument characteristics. There are some very wide swath instruments that will see the entire globe every day or every 2 days. And so if you're thinking of the answer to your question in terms of, I'm at this point in space, how often does the satellite see me? It can be as quickly as every day. There are other instruments that are very narrow swath that will only see you, say, every 2 weeks. So from that point of view, it depends on the characteristics of the instrument. If you're asking about how quickly the data are available to you, generally speaking, the instruments my group works with have a latency of on the order of 6 to 9 hours. And so after the satellite actually collects the measurement, it's available. The geophysical or interesting data products are available within 6 to 9 hours. Looking at that question one other way in terms of performance, NASA and a number of our international partners spend a lot of time, energy, and money on doing ground campaigns to evaluate the performance of the satellite. And so it'll depend on whether you're doing a land validation or an ocean validation. If you're talking about ships, it's not nearly as often as, say, you were able to fly drones or use gliders or floats that can go out into the ocean. But we try to do everything in as near real time as possible, because there are a lot of societal applications of this data too. So, for example, if I'm looking for forest fires or a volcanic eruption happens, or I'm trying to monitor, say, harmful algae on a coast I care about where I might have to close the beach, you want to have that information absolutely as fast as possible so that you can respond. And we try to pay attention to that.
All right, thank you very much, Dr. Wardell, again for your excellent presentation, taking the time for this question and answer period. I apologize to all our other participants who submitted excellent questions. Unfortunately, we had a little bit of limited time for this session. But thank you all for participating, and now I'll hand it back over to our talented MC, Marian, for the next session.
Thank you all. This was a pleasure.
Thank you, Mr. Lambert and Dr. Wardell. Next, let's welcome another speaker, Mr. Huaipu Chen. Mr. Chen is Taiwan's youth representative of our Ocean Conference 2022, and he currently studies electrical engineering at National Taiwan University. He's going to share his experience at our Ocean Conference in Palau this year. Let's welcome Mr. Chen.
Hi, my name is Huaipu Chen. I'm here to share the experience of attending our ocean this time in Palau. I was selected as one of the 13 members of International Youth Delegate to join our ocean this time. And the other International Youth Delegates are from Cook Island, Canada, Egypt, Panama, Papua New Guinea, USA, etc. And we are so excited to join our ocean this time because our ocean was a very high-level ocean conference. But my first story happening in Palau was actually very scary. If you can see, our car stuck on a very wild road by a tree branch under our car engine. And there's a short video I can share with you.
Once pristine, once untouched, once pure, all of that's no longer there anymore. Stripped down torn apart, chipped away a piece of our heart.
Something stopped.
Yet still we
the tree branch.
yeah. Like the wind we still move, like the waves we rise high, like the sun we never die. We will stay standing. Hear our calling. We are rooted to the ground. We're here to stay. No staying quiet. We stand united. We are rooted to the ground. Can't tear us down. We're here to stay. Oh, 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 oh. We're here to stay.
Okay. So after that, we go to meet local Palauan. They teach us to plant trees in their own unique Aboriginal way. And they also share a lot of thought and perspective of looking economic and Mother Nature.
The place we're going to?
It's very funny that it's a very common way to move from point A to point B in Palau. We hitchhike a farmer truck there, and we success. And it's other international Taiwan international youth delegate join my hitchhike. Along the way, it's very proud to see the friendship between Taiwan and Palau are so deep. A lot of road signs, and even in front of the presidential office of Palau, there's a signature of Ma Yingjiu over there. And it's quite interesting to share the relationship between us for international youth delegate. Every day in Palau, there's beach dinner over there. We can grab some food, get to know with each other on the beach. And we talk everything. We talk the project we have conducting, the project we will doing, and how we can collaborate, even the story happening in Palau. And I also share my project of designing a new kind of fish tag with them. And there's even a floating plate that you can step on there and grab some food and talk with each other. And you can see the seawater was surrounded by us. If you know what the GT is it giant trevally. It's a 1 meter long fish. And it's very uncommon to see this scenario happening in Taiwan. But, you know, in seaside dining, I see a lot of this kind of scenery, like a very big fish, even a mahi-mahi or a giant trevally, preys on small fish. And we see the fish at the same time we discuss with our youth commitment. And I will mention the youth commitment later, but it's very important. Here's the point. On the first day of our ocean conference, we got the permission to get into the plenary hall. It's inside the plenary hall. Under the stage, it's more than 2,000 high-level officials around the world. This Our Ocean Conference 2022 has 6 different kind of themes, ocean themes, and they have panelists to discuss these 6 things, like ocean acidification, ocean pollution, sustainable fishery management, etc. On this panel, the moderator is the director of NOAA, and he's discussing how to use the scientific-based solution to solve ocean acidification problem. And here are some photos. Of course, I witnessed a historical moment of Taiwan. The director of EPA Taiwan, Zhang Zijing, he go to the stage and share Taiwanese technology with other international high-level officials. Here's our youth delegate. And as I mentioned before, we have discussed our youth delegate for 2022, our ocean. And our representative, Kalani Reyes, from Northern Mariana Island, represented us to go to the stage and talk a 6-minute speech of our youth commitment. She's very brave, and she inspired me to seize the opportunity to talk in the future. Here's some interesting reflection of mine that age doesn't matter. They only care what you have done in your early 20, even early 25. If you have unique experience or unique project you want to do or you have done, and you have the skill to be clear to say what you want to say in a very short time, they are very willing to hear the perspective of you. Because I saw a lot of young panelists, they are only 25. And they inspire me that in Taiwan, we always think that, hey, I'm just 20 or 25 and I don't have a lot of experience, so I cannot go to the stage to share my experience with 200 or 2,000 high-level officials. But it's totally different in happening in our ocean. Everyone sees the opportunity to talk loudly and contribute your unique experience to our ocean. Therefore, I grabbed every chance I could talk in the next few days. I was the first one to raise my hand and share what I want to do and the experience of Taiwan for John Kerry, the U.S. Special Presidential Envoy for Climate. And I think I was very brave to say that because I get a lot of precious opinion and suggestion from John Kerry. Of course, it happens the same with other high-level officials, like the director of NOAA, Renewable Energy Agency, U.S. Environmental Protection Agency, a lot of director of NGO, and the director of NASA, and ambassador around the world. I have the connection with them. Here's another reflection. Very important to quickly immerse myself into local Palauan and local culture, like what they are wearing and the pace, very slow pace, and the spirit. The spirit means that the respect to the mother nature and respect to the people. You only need to bare your heart to everyone you meet in our ocean, and try to talk more and share your unique story. They would like to listen to your story and try to contribute your unique experience. Of course, play hard because you work hard. So in the next page, I want to share one video of how we can play hard. Here's the video. go to the Rock Island. It's a very beautiful beach. It's a remote rock. This photo was taken on Jellyfish Lake. Okay, so remember, try to play hard. In the final 2 pages, I want to share 3 people I met, which was stunning. The first was called Ren Jie. He was the first Palawan I met, can speak Chinese. And he shared with me a lot of relationship story between Taiwan and Palawan. The right one was Samam. He was from a very small island, Maldives. Samam knows my profession was in engineering, especially in ocean engineer. He know I've done so many experience on ocean wave or sea current generator to generate the electricity, self-powered electricity. And if you know, Maldives was one of the lowest sea level country in the world, and they are surrounded by the ocean. And Samam told to me that, hey, bro, Samam was greatly impacted by the climate change, and he wants to find a way to save his home. He said he wants to generate the power from ocean surrounded by Maldives to get electricity self-supply for their own country, but he didn't know how to do it. So he invited me to go to Maldives someday, try to, maybe I can design an ocean wave generator for their country, because in their country, there's no professions in ocean engineering. And the last one was very important because my project was designing a new kind of fish tag, self-powered fish tag for bluefin tuna, but I haven't tested on a bluefin tuna. So I found Jennifer Dianto-Kremley at our ocean. She has 10 plus years of experience of tagging bluefin tuna. And she also have a very big bluefin tuna farm. So I found the right person to test it on a real bluefin tuna in the future. I learned a lot on this trip. I also contribute a lot of my unique experience for our ocean. And I hope you could do so. Thank you.
Thank you, Mr. Chen, for sharing with us his wonderful experience. We will now have a break. The next section will begin at 10:35. I'll see you later. Now is the time they were all looking forward to, the presentations of the finalists. This year's competition includes 4 categories: college and graduate school teams in category A, high school teams in category B, young professional teams in category C, and international school teams in category D. A total of 19 finalists were selected to proceed to the final round. Each team comes up with a science-based solution that addresses an ocean issue. They all have a chance to win cash prizes and the Best Proposal Award with a grant of up to 100,000 NT dollars to implement their initiatives. Before we get started, let me acknowledge our judges for today's competition. Dr. Jian Hong Chen, Vice President of National Academy of Marine Research. Dr. Zhang Ying Jessie Ko, Associate Professor of National Taiwan University. Dr. Chong Ling Chen, Professor of the National Chen Kung University. Dr. Ta Kwang Liu, Professor of National Chen Kung University. And Dr. Tong Yun Fan, Research Fellow of the National Museum of Marine Biology and Aquarium. Each team will have 10 minutes to present their proposal. After the presentation, the judges will each have 2 minutes to make comments and ask questions. The winners will be decided based on the following evaluation criteria: relevance, effectiveness, innovation, feasibility, and the performance of the Q&A. Ladies and gentlemen, let's start Ocean Challenge 2022 presentations. Beginning with young professional teams, please welcome Team Matsu Fish Conservation Union Taiwan with their proposal entitled Investigation of the Coastal Directed Fishing Gear in Zhanghua and Yunlin County.
Good afternoon. My name is Guo Jiawen, and I am a researcher for Royal at Heart Legal Defense Association Taiwan. Throughout my research, I have encountered endangered animals sliced and scarred by fishing gear. What should be a safe nature environment for our marine wildlife has turned into a death trap. That is the problem we aim to solve with our Ocean Challenge 2022 submission. Don't let our waste cost go to waste. So as the human population increases, so does the amount of waste we produce. When this waste is not properly recycled and handled, it creates a huge burden on the environment. Marine litter in particular has been receiving more and more public attention. It can include litter scattered along the coast, floating in the water, or on the seafloor. This litter, 7% of which is fishing waste, can catch, entangle, and strangle marine animals, leading to their injury and death. On Taiwan's western coast, the sandy soil sediment is prime fishing ground, but fisheries equipment often gets abandoned. Whether that's deliberate or due to equipment catching on something on the seafloor, this abandoned equipment contributes to a ghost fishing issue when it catches non-target species like dolphins and sea turtles. Ghost fishing not only worsens marine pollution, it also has negative social and economic impact as it wastes marine resources. Just this February, a live leatherback turtle has found entangled in an abandoned fishing net on Fulong Beach. The turtle was treated by the Ocean Conservation Administration and other institutions, but ultimately dead. So clearly, there should be a more effective response to fishing waste in order to prevent this kind of situation from happening again. One of the animals most often caught up in fishing gear is Susachiensis taiwanensis, or as we know as the Taiwanese white dolphin, also called matsu fish. It is classified as an extremely endangered species since 2008 by IUCN. There are only less than 60 individuals left. The Taiwanese white dolphin is found only in the shallow water off Taiwan's western coast. This is a place where fishing activity is bustling and fishing waste is a huge problem. Gill nets and trolling are especially frequently used along the west coast, which contributes to many white dolphins having often fatal encounters with fishing equipment. Here you can see how three Taiwanese white dolphins, Joker, Cupcake, and Joker's younger sibling. Cupcake is Joker's mother, and his family. In this family, they are all injured by fishing equipment between 2011 and 2016. They have scars and even fishing lines wrapped around them. Earlier this year, Joker has unfortunately found stranded and dead in the South Dike of Anping Fishing Port in Tainan. The autopsy showed that Joker has had scars from foreign equipment, not only on his mouth, but also his body, and developmental abnormality due to injuries caused by past fishing gear entanglements. These scars were in different degrees of healing, so he had many different encounters with fishing equipment. So along that vein, we have designed our Ocean Challenge proposal with the goal of improving environmental quality along Taiwan's western coast to conserve and restore white dolphin populations. Our proposal focuses on the areas of Zhanghua and Yunlin since first. Zhanghua is where the north and south tides converge, so it has the largest tidal range on Taiwan's west coast. And then Yunlin is one of the core areas that white dolphins frequently sighted. So we aim to catalog fishing waste types and quantities in these two areas. This data we will then use to produce a report that can be used by relevant management authorities. To be more specific, we will host 4 two-day beach cleaning events in Zhanghua and Yunlin. At these events, we will collect things like fishing nets, fishing lines, oyster lines, floats, sinkers, and other fishing gear. Every collection will be counted around a GPS point that we record in order to avoid going over this area twice. And the information on the fishing gear we collect will be outlined in a comprehensive report. As you can see, this project will be a cooperation between Taiwan Matsu's Fish Conservation Union, Wildcat Heart Legal Defense Association Taiwan Watch, and Yunlin Offshore Fishers Association. The cleanup will be supervised by Robin Winkler, chairman of Matsu Fish Conservation Union. A variety of personnel will be involved in coastal surveying and topographic analysis and planning of the cleanup itself. In this table, you can see the cost estimated. We have calculated for different aspects of the project, with travel expenses, workers' salary, and rent making up the majority of total cost. We estimate the total cost of this project to be 253,000 Taiwan dollars. Our report will take into account and respond to on the one hand, current fishery management and operations, and then along with that, fishing waste and its treatment. The report will include a statistical analysis of the types of and quantities of fishing waste, and there will also be a proposal on how to improve fishery management and better treat fishing waste. This information is valuable to related institutions in the government and fishing industry alike. And with that, we would like to thank you for your attention and reiterate the urgency of solving this issue of marine litter so that not one more Taiwanese white dolphin gets entangled and strangled, because we cannot spare to lose even one more dolphin. Thank you very much.
We all realize Taiwanese white dolphins is important in ocean ecology and ocean conservation in Taiwan. So I feel your project is important, but I just wondering, your project only plan to implement 4 cleanup events with 2 days per event. Do you think they are enough? If they are enough, any specific time would the team suggest? Second, the project mentioned the maximum amount of marine debris they collect is 4 tanks. How about the representatives? Thank you.
I appreciate the effort of this association. Has a long dedication to the conservation of Chinese white dolphins. And the proposal, I'm also quite interested, which try to reduce the fishing nets problem. But here I also have 2 minor questions for the team. The first one is that we know that we monitor, we record the location of the fishing nets, but how we use this information, how we utilize this information for further actions to reduce the stress of the fishing nets on the Chinese white dolphins. This is the first question. And the questions, in addition to clean up operations to remove fishing nets at the beach, what would be more active ways do you think that can further reduce the stress posed by the fishing nets on the Chinese white dolphin? Thank you.
Okay, I have 2 questions for you. The first one is that the government has listed 6 major threats for the Chinese white dolphin in Taiwan. And in your opinion, as a local NGO who care a lot for this issue, what is the #1 threat for the Chinese white dolphin? The second question is, are the location you choose the hotspot for sighting the Chinese white dolphin, or do you have experience sighting them? And please share your experience.
I have only one minor question for you. There are many beach cleanup activities in Taiwan already. So could you please briefly identify the new aspects of the cleanup action you plan to take in the proposal? Thank you.
Yeah, I think this proposal is very important for conservation of the dolphin. But could you propose some evidence? What's the direct relationship between beach cleanup and the white dolphins activity? And the second question is there any other active way to conserve the white dolphins? Like you can collaborate here with fishermen. Is it possible? Thank you.
31. Okay, thank you, panelists, for your questions. So we've got 5 minutes, so I will take the lead on this. The first question from Professor Ko, whether or not there's enough time that we're doing the cleanup and enough, and whether, as we understand it, whether or not what we're going to collect in the 4 barrels is representative of the waste. I think that the time factor, this is something that we've been doing now for years, and these are just 4 more events that we're going to do, and it's never enough time because the amount of waste is endless. But and whether or not the waste that we collect this time or the trash that we pick up from the beach cleaning is representative, our experience shows that we're pretty close to what the EPA and Ocean Affairs Council believe is the composition of the waste that's collected in the beach cleanups. Professor Chun, with regard to fish nets, how we will use the information to reduce the threats. Well, we believe, and this is kind of goes to Professor Chun, another question as to what is the major threat. But the information on the fish nets is, we believe, addresses the #1 threat to the dolphin. And this is something that the international community, since 2004, the first international workshop on the Taiwanese white dolphin, some of you refer to as the Chinese white dolphin, on the Sousa chinensis, taiwanensis. In 2004, it was noted that among this genus, fishing nets are the major threat. So this is the at least 4 species: East Africa, West Africa, Indonesia, Australia, Southeast Asia, China, and Taiwan. So I think that the information that we gather from this will be useful in talking with the EPA and the Ocean Affairs Council on how to address the threats of the gill nets. What is the #1 threat? I believe that I addressed that. We have thought for some time that the #1 threat is the nets, the fishing nets, and those are active nets as well as ghost nets, abandoned nets. And regard our experience citing the Jiawen with me was with the original team in 2003 and 2004 that originally discovered, scientifically discovered the Taiwanese white dolphin. We've all of us here, except 1 or 2, have been out. We've done land-based observation, boat-based observation, and we have all seen, most of us have seen dolphin, the Taiwanese white dolphin several times. Evidence that the beach cleanup will help the dolphin? Gosh, that's really hard. I think no matter what, beach cleanups are good. And whether or not we can establish a direct link to actually solving the threats to the Taiwanese white dolphin, I think is something that need to work on. And Professor Fan mentions, are there other ways, such as working with fishers? Absolutely, yes. We work very closely with fishers in Yunlin. One of our members is also in Jianghua. We've met many times with the Miaoli fishers. So the fishers are key to the success of conserving the Taiwanese white dolphin, which is why we will continue to work with them closely. Now, I do mention Taiwanese white dolphin. I just wanted to point out the reason that we use Taiwanese white dolphin is that this is a distinct population recognized by the IUCN since 2008, and they have no back and forth, no contact with the Sousa chinensis, the Chinese white dolphin that is on the other side of the strait, Indonesia, Southeast Asia, and so forth. So I really hope, for the sake of conservation and underscoring that this is a critically endangered population of probably fewer than 60 animals, that we all adopt the name Taiwanese white dolphin, Taiwan Baihaituan. Scientific has been, this has been done in SCI peer-reviewed papers.
Thank you to Team Matsu Fish Conservation Union Taiwan for their presentation. Next, I would like to call upon the second finalist, Team Asia, with their proposal entitled Fight for the Asia Ocean.
Hello everyone, I'm Chue Chen, a co-founder and the CEO of Asia Alliance. It's a great honor to introduce our project today, Fight for Asia Ocean. It's a marine debris removal project developed in the 2017, beginning from the bathtub to the fishing port. More than 8 billion tons of plastic enter the ocean, and it's harming more than 800 species. It's estimated that 80% of marine debris is land-based garbage. Marine debris emit from single species to the ecosystem, bring negative impact to human coastal economic industry, food safety, human health, and contribute to climate change. Here is a video showing the 4 major challenges of traditional marine debris removal implementation. First of all is manpower shortage, which includes the difficulty of training operators of clean boat. Also the difficulty of recruiting because the occupation safety is higher. Second, the purchase of clean boat is expensive, which cannot be afforded by the finance of different authorities, and the maintenance cost is also high. Third, the existing clean boats are working in a limited area due to their large size and the deep drift. Fourth, using fuel as power does not meet the expectation for the air pollution and the carbon emission reduction. There are major reasons cause the difficulty of effective marine floating debris removed. Taiwan has one of the highest density of fishing ports around the world. However, due to the limitation of traditional marine debris removal implementation, there have been a lot of obsession of debris floating on the fish port surface. There are different compositions of marine floating debris by season and location. However, plastic is always the major one. To implement the Paris Agreement and lead the global fight against climate change, the Asia Fighter and the project were designed, built with intelligentization, electrification, and digitalization. About the goal of intelligentization, numerical control is an effective innovation of mechanical product. It also enhances the ability to control mechanical product movement and the tracking process, and enabling the machine to process multiple functions, high level of flexibility, high precision, high performance, greater reliability, and easy in operation. On electrification, Asia Fighter was designed with electric power, with mastering energy efficiency, reducing carbon emission, and being environmentally friendly. About digitalization, we also pay much attention on collecting and mastering spatial and debris distribution information. Digital technology also provides a new opportunity for contributing to marine debris governance and environmental policy. Asia Fighter is a remote control category that took 2 years of research and development. Let us show how it works. Azure Flight is a remote controller catamaran with a global navigation system and a 2.4G 5G connection. Azure Flight with a length of 3.8 meters, width 1.8 meters, which can pick up floating garbage with 100 kilograms per trip. The greatest speed has achieved 10 kilometers per hour and reached 8 hours active with under 5 hours to charge. Furthermore, as an electric marine vacuum cleaner, Azure Flight can reduce 2,517 kilogram carbon emission compared with a gasoline-powered clean boat, and it works in water environment such as port, canal, lake, river, and pond. Every time people ask about how much marine debris could be removed by Azure Fighter, Azure Fighter makes an 11.8 completed tour of the Shenzhen fishing port in a day, which an average speed of 3.7 km per hour and under the 100 kg marine debris removal capacity per trip. A total of 1,000 kg of floating debris could be removed per day. Now, we focus on building a new Azure Fighter and implementing it in the fishing port to do the better practice of the innovative clean technology to achieve ecosystem protection. Here is a render of a new Azure Fighter, which will complete in the coming months. We are training more operators and creating standard operating procedure right now. This year, for building the standard operating procedure for Azure Fighter to make it work well in deep and shallow water environment, we will operate 2 demonstration pilot projects, one in Zhuwei Fish Port and the other one in Beetle Fish Port. Then we look forward to implementing it in more areas in the future to protect our ocean. To cut off floating debris journey from the coast to the ocean, we have developed innovative technology and made it practice together with different stakeholders. We are happy to invite everyone to join us, fighting together for Azure Ocean. A technology can bring ocean back to the Azure Fighter, from pollution to solution. We want ship blue and we make it come true. Thanks.
I'm so happy that we will have Taiwanese marine litter collector. If so, Taiwan can play a critical role in the international organization, and it will show Taiwan's determination to environmental governance. Because I think you have real machine, I do look forward to your further development. However, I still have a couple questions that I want to ask the team. First, could you give us a comparison of your collector and other international collectors? We want to know more about the advantage and disadvantage of your design. Second, when will your collector plan to work? Daytime or nighttime? How long will it take per cruise? Because I would think if the collector will stay more time in the port, so it may have a conflict with other boats or vessels. So how would you plan to work the collector? Thank you.
Okay, I appreciate the team's efforts to make a new type, okay, litters cleaner, okay, and used in the harbor areas. But here I have 2 minor questions. The first one is that I just wonder where the device is placed at the harbor. Could you be more specific on the location that this device is suitable for this device to be placed at the harbor? Okay, and what would be the size of the marine litter that this device can collect? I think maybe you need to be more specific on the features of this device, and these features maybe can reveal some information why this device is different from the ones used at the international community. Okay, and the second, in your proposal, you try to use the AI in this device. But I just wonder, is there any equipment equipped in this device such that this equipment can learn how to identify marine debris? I just do not have any idea on how to utilize the AI in this device. Could you please specify more on this point? Thank you.
I think your design is very interesting, and I admire your courage to develop such a device. But I wonder what is the capital cost and the maintenance fee for your Azure Fighter? Since it is remotely controlled by a user on the shore side, I wonder how far it can operate offshore. Please explain. The second question is, since this is a new design, I guess there is still some minor problem or fault for the Azure Fighter that you are still improving it. Can you share your experience with this?
Yeah, your design is very impressive. As far as I know, the Azure Fighter has won many prizes in the past few years. So this must be a very successful one. Could you please briefly identify the new features of the system you prepared for this contest? This is the first question. For the second one, the question is actually similar to Dr. Ke. Compared to other ocean debris collectors available in the world, what is the most significant feature for your system? Thank you.
Yeah, this proposal looks very promising, and since ongoing project, I'm wondering what's the most difficult work for this project to scale up the application in other places in Taiwan, and is there any other successful case internationally for you to learn and to share your experience with them, so have a larger impact in the world? Thank you.
First of all, thank you for all your interest in our Asia project. And this is Gigi. I'm the chief engineer of the whole system development. So first of all, I would like to briefly go through the core competence of our vehicle. And the first point is the ease of maintenance. So as you may notice, our vehicle use like a gasket to collect all the waste, and then we can take all the trash directly out from the vehicle without like entering the water or move the vehicle around. And the main difference between this design and others is as for one of our competitor, Water Shark, they use like the whole vehicle as like a collector. So when they need to take the trash out, they need to lift the entire vehicle up away from the water, which will be a lot of human resources and quite time consuming. And also other vehicles such as like water jelly bot, they use like a net to collect the waste, but the problem with like using net is the net can easily hook up to obstacles and cause like kind of vehicle problem or shortage. The next highlight we would say is the handling. So for our vehicle, we do integrate like anti-collision system and also the bumper. So in this way, we can prevent the vehicle from bump into other operating marine, such as like fish boat or other marine or boat on the seashore. And lastly is our control feature. So for our range, we can reach up to like 3 kilometers of control range. So in this way, we can quite easily locate the vehicle position and also make sure we do have stable signal from the overall vehicle operation. And also lastly, we want to emphasize on our AI technology. So far, we haven't integrated the AI onto our vehicle yet, but we are developing an autonomous driving version. So in that case, the vehicle can operate by itself using the AI and machine learning. Then we can save like human resources and manpower on the overall project and development.
Okay, next.
Casey.
Okay, I want to answer the question for Professor Chen and Professor Jesse. So, Agile Fighter is able to operate during day and night, but we prefer to operate only in daytime, in order to prevent the risk of collision and by the other huge boats and even the reef. And our normal operate time is 2 hours per day. And if in some special case, overall operator with battery fully charged could be around 6 to 8 hours. And yes, you are right. We need to keep away from the huge boats. And one of our limitations for Agile Fighter is the rainy day with the big wave. So in this case, we also prefer not to take the risk to operate the machine. And the question from the Dr. Chen, Agile Fighter has operated in both shallow water port and deep water port. And right now, Taoyuan Zhuwei Fish Harbor is one of our demonstration ports to let us to perform the prototype machine test and also collect the local marine debris. This is very important for us to build the data and SOP. For the size of the marine debris, we can collect less than 60 cm, and you can imagine we are able to collect the livelihood supply like the wash basin, and even one of the most common marine debris is floating boat. And if the size is as small as float stone, which is the machine disaster in few months ago, we can also have different modules such as filter to install in our conveyor. That's my presentation.
Okay, next is me. I'm the CEO of Agile Alliance. My name is Cher Chen. Our main challenge lies on the business model. In other words, we haven't figured out how to generate stable income. Also, we need more effort on developing sustainable environmental model, including finance, social influence, environmental impact, and organization culture. Therefore, we have talked to the Kalimbo team to better understand their approach for the business model and the environmental development. For our next step, we are going to participate in the International Marine Debris Conference in this September. Hope there is an opportunity to demonstrate Agile team progress so far and learn from the world about how they deal with environmental impact.
Thank you to Team Azure for their presentation. Next, please welcome Team Indigo Waters Institute with their proposal entitled Detection, Orientation, and Removal of the Dendritic Oyster Quartz in Taiwan's Coastal Muddy Waters.
Hello everyone, we are Indigo Waters. I'm Ning, the project leader of our team. Today I would like to present our proposal, Detection, Orientation, and Removal of Derelict Oyster Quartz in Taiwan's Coastal Muddy Waters. Taiwan is an island located near the biggest fishing ground around and the Southeast Asia region, where we release great amount of plastic. People may wonder what's the situation of marine debris pollution in Taiwan. In the past 4 years, we conducted several surveys of coastal debris with a visual quantification method. To be brief, we record the volume and type of coastal debris around Taiwan. We were surprised to see that 70% of the coastal debris is relevant to fisheries and aquaculture. You can see the map at left. The red is the waste of aquaculture, and the blue is the waste of capture fishery. Most coastlines only have 20 to 30% aquaculture waste. However, in the southern western part of Taiwan and Penghu Islands, there is about 50 to 60% of aquaculture waste. When we talk about aquaculture waste, there are three types of them: oyster raft, foamed buoys, and oyster cords. The government has already adopted some retrieval and treatment scheme for the top two, so our target is oyster cords. Oyster cords are made of nylon, which has high value in recycle market. It can be used for making functional outdoor outfits. Currently, in Jiayi County, the oyster industry produces 1,375 tons of oyster cords every year. If we can utilize this material, then we can close the loop and create circular economy from the aquaculture waste. The United Nations has set the Sustainable Development Goals. Our project echoes with the Target 14. Through our project, we can reduce marine pollution, protect marine and coastal ecosystem, and we can conserve coastal and marine environment. Here, I would like to present the current situation. Two photos at left side is from our sea bottom survey in 2020. You can see there were a huge amount of oyster cords at sea bottom. When we interviewed aquaculture fishermen, they also mentioned that some fishermen just disposed oyster cords into the sea and lagoons when they operate at sea. However, no one has noticed this issue. Neither the government sector nor research institute has ever identified the pollution level at sea bottom in the aquaculture waters. So here is our plan. First, we will detect the abandoned oyster cords at sea bottom. Then we will use orientation tools to locate the hotspots. Later, we will develop suitable tools to remove those oyster cords from the sea. When we collect oyster cords from the sea, we will cooperate with recycle company to use these materials as new products. We believe this is the best way to utilize the material and reduce its impact to the environment. The photos below show how we test our system in lagoons and fishing ports. In the following slides, I'm going to introduce our system in detail. First, here is the underwater detection system. We have done some literature review and collected case studies from other countries. The concept is to develop a system that can be towed by a vessel, and my team can operate from the vessel. Our system includes a high-resolution camera with its housing and 2 LED lights. We fix the camera and lights with a frame that can be set on a vessel. We also create a system that image can be transmitted from underwater to the vessel in real time. And our team can monitor the real-time situation and control the system on board. The photo at right bottom is the frame, the camera, and its light. Second, we have tested the system from this February. You can see the photos taken from the lagoon and the fishing ports. There are oyster cords, rope, and even a crab. With camera and light, we can understand the underwater situation. Currently, we are testing the buoyancy of the system in confined waters. After we finish adjustment, then we will test in open waters. We aim to test the protocol with a small vessel in August to October. The next step is to develop a suitable tool for removal. We have also done literature review, and you can see there are various kinds of design. We will make our own design, develop the tool, then test and adjust in the following stage. Last but not least, I will introduce my team, our timeline and budget. This is our team. I'm Ning, the project leader. My colleague Jason and Jixuan are responsible for methodology design, system development, and field survey. We have solid experience in marine debris survey. In the past 3 years, we have conducted coastal, sea bottom, and riverine survey of debris. Besides, we are also the first research team to record and compile the derelict fishing gears on Taiwan's coastline into a guidebook for the public. We believe that only we cooperate with more people, then we can solve the problem of marine debris. Thus, we are active to share our outcomes with others. We have already published 6 papers in peer-reviewed journals. We are confident that our experience and expertise from Taiwan can help others. We are ready to work with regional and international allies. Here is our timeline. We have done early preparation and literature review. Currently, we are testing our detection system. Later, we will test our protocol. In Q4, we will develop and test the removal tool. In the meantime, we will document the process with photos and videos. We aim to produce the removal tool next year. By that time, we can use our system to detect and remove the oyster cores from the ocean. Our budget is about 1 million NTD dollars. Most expenses will be used in salary and development of our system. That's it. Thank you for your attention.
I appreciate the team always has sensitivity observation for environments in Taiwan and always show your good organization about your project. So for this project, I have the main question about your budget. Because I see your budget is quite cheap. So I'm wondering about how you will design your detection tools and removal tools. Are you going to buy the existing device or you will do your own independent research and development of the detection tools and removal tools? Thank you.
This team seems to me is dedicated to solve a single problem, which is the oyster line detecting problem. And we know that in turbid water or in the water that the visibility is very low. It's very hard to detect the oyster lines. So I just wonder how the device can cope with this problem. I think you need to specify more on this point. Especially, it's very hard to detect the lines in the turbid water, and further to differentiate the objects, the normal objects under the sea, and the oyster lines floating in the sea. And the second question is that I wonder how much the cost need to be invested in the design, developing this device. I think you need to specify more on this point. Thank you.
Okay, I have 2 questions for your proposal. The first, do you have a rough number how much oyster core were there in the sea bottom? I mean, when the farmer harvests 1 kilogram of oyster, they probably discard a certain amount of the oyster core. Have you ever calculated the amount of oyster core being discarded every year? The second, do you plan to reuse the oyster core after being removed from the seabed? What's the market value? I was told that the market value is still less than the effort to remove them, so the government subsidy is still required. What is your opinions on this?
First of all, I would like to congratulate on your clear presentation. And I have two questions for you. For the first one, to remove the oyster cores, you pointed out in the presentation, you plan to develop suitable tool. Do you have any more concrete idea what it will be at this moment? For the second question, you talked about the recycling of the oyster cores at the beginning of the presentation, but did not have any words in the later part. Could you please briefly describe this part? And how much could be removed from the sea bottom, I mean the oyster core, and how much revenue would it be create each year? Thank you.
I think this proposal is very interesting and also challenging. So could you describe what's the most challenging work for your proposal? And I'm very impressive. You are very good at the research and publication. Could you share your successful experiments with us? And is there any other plan you want to collaborate with researcher or professors so make this project more successful? Thank you.
We are Indigo Waters. I'm Ning, and here are my colleagues Jason and Jixuan. Thank you for your recognition and questions. I would like to reiterate that what we are doing has never been done in Taiwan before. There lacks research on the amount of sea bottom debris. As a result, no one can estimate how much amount of the oyster cores are there on the sea bottom. Once we start the survey, we will get the initial data. Our project is a pilot. We will kick off in Jiayi, and this is just a start. The system we develop can be applied to more places and even to other countries. We are open and look forward to cooperate with the government, research institutes, industries, and even with the global partners. In fact, we have reached potential cooperative partners such as the international NGO, GGI, Global Ghost Gear Initiative, who concerned about derelict fishing gears a lot, and they are quite interested in our projects. Besides, we have spoken to Formosa Chemical, who are capable and willing to use chemical recycle on derelict fishing gears. We have also visited the largest fishing net recycle company in Taiwan, and we have learned that the market value of recycled nylon is growing since European and American markets have more demands on recycled materials. The most challenging thing for us is money. Until now, we devote our capital, human power, and time into this project, and we realize we underestimate the budget. The budget for developing the system is about $1.5 million, and the following tools for detection and retrieval will be $500,000. As you see, we have strong research capacity, and we are confident to contribute our knowledge and experience to more people. So please support us and help us to make this project come true. In the following session, my colleague Jason will go through the technical part for you.
Hello, I'm Jason. This is our prototype. I can show you on the screen here. It's about 50 centimeters long and at about 30 meter height. And actually, the basic structure is it's a tow camera, underwater tow camera, and we will use this to find and locate the derelict fishing gear and the net at the sea floor in the Taiwan coastal waters, and especially in the low visibility areas. So let me go deeper of this prototype. We use polypropylene and aluminum alloy to have the strength and both the lightness as the main structures, and the buckles and the cables are made of stainless. So this is a prototype, and we will use this kind of stainless cable to make them a tow camera, and we use two optical facility to record the underwater images. So we have this wide-angle camera here, and this ultra ISO high-resolution, high-sensitivity camera. The highest ISO value can be 12,000, so it can be record the images in the very low light conditions and dark conditions. And we also have some LED trays, and with 3 different colors. They have white, blue, and yellows. So we use the side lighting to decrease the scalping caused by the suspend particle in the waters. So our goal of this system is to use on a small powered boat that we can tow on this camera on the bottom of the basic area of near shore, so to record the basic condition to recognize is there any direct fishing gear. And now we are working on the buoyancy adjustment, and we're also working to reduce the chance of entanglement and design a escape device. And we will optimize the system that we can control and process position of the camera from the boat. In the meantime, we have finished the synchronized transmission of underwater images by using the 2.5 and 5 gigahertz Wi-Fi antenna and the coaxial cables. The idea is just like this, but
Thank you to Team Indigo Waters Institute for their presentation. After the morning presentations, it is now lunchtime. Please enjoy your lunch, and we'll come back at 1:30. I will see you later.
Ladies and gentlemen, we'll now begin our afternoon presentations of Category B, High School Team. First, I would like to call upon our first high school finalist, Team Ocean Savers from Taipei Fuxing Private School, with their proposal entitled Oil Packaging Apparatus.
In the past decade, there were 164,000 tons of oil loss, and one incident was responsible for about 70% of that number. Even though oil spills made up only 12% of the oil that enters the ocean, we can't guarantee another massive oil spill wouldn't occur again. And when such a large quantity of oil is spilled into one place, it can still be catastrophic to local marine wildlife. In Taiwan, in 2006, the oil spill of the Maltese cargo ship Jinny off the coast of Su'ao caused a catastrophe on the coastal corals. Other incidents such as the Panamanian cargo ship Chenxi and Ruixing off the coast of Shimen and Keelung City, and the Dexiang Caihe in the Shimen waters, all caused irreversible effects to our sea. Other than specific incidents, untraceable oil pollution is found on the north shore of Lidao. Not only is the cleaning process labor-intensive and time-consuming, more tar lumps are constantly coming with the tides. Seasonal factors such as the monsoon blows can make the areas more susceptible to oil pollution because of the increased frequency of ships running aground. What's more is that Taiwan is located in an area with frequent international shipping, with at least 1,000 ships passing through the nearby waters every month. It is very hard to trace the companies that cause the oil pollution if the government doesn't respond immediately. Knowing how oil pollution jeopardizes our sea, we also want to know the current solutions. One way is to use the oil boom, a fence that covers the oil, to stop it from diffusing and pump the oil into a ship tank. However, it takes days for the cleaning ship to arrive, allowing oil to spread freely. Another method is to burn up the oil, which kills organisms, raises sea temperature, and wastes tons of oils that could have otherwise been recycled. Our oil packaging apparatus has three main advantages. First, mobility. The physical appearance of the apparatus makes them able to move faster, decreasing the time needed to travel to the oil spill site. Moreover, while it takes traditional cleanup ships days to arrive at an oil spill, our light apparatus can be transported through helicopters. While our apparatus can continuously separate oil from water and depart capacity from its body, traditional ships can only do one-way cleanup and have to return once its tank is filled. On effectiveness, multiple smaller ships can be more effective since multiple oil collecting points can fit the direction of the current. Similarly, our products also win over sponges. By dividing oil storage and oil separation into two different processes, the apparatus will be able to make waste oil bags persistently. Direct suction of water using pumps makes our apparatus process faster than sponges do. The strength of our product is its speed and capacity. Efficiency is achieved through the rapid separation process and the short traveling time. Capacity is maximized through filling oil into rubber bags, separating them from the apparatus itself. Our model also reduces the requirements for a cleanup ship, allowing more to engage with the cleanup. Furthermore, when ships run aground, oil left in the tank could be pumped into the rubber bags to minimize the amount of oil leaked into the ocean. The inspiration of our model comes from the combination of oil containment booms and weir oil skimmers that can maximize the amount of oil collected and minimize the time needed. The oil-water separator eliminates unnecessary volume taken up by water. The oil packaging machine comes from the rapid fill water balloons, where the balloons fall off automatically after being filled. Our machine is similar to it as it fills oil into rubber bags with valves allowing it to fall off the hose after being filled. Our design includes four main features: water pump, centrifugal oil water separator, packaging machine, and multiple floatable oil containers. The apparatus would sail over the area covered with oil, collecting them with a pump. Oil would be transferred through the collection pipe, separating them from seawater simultaneously. The separated oil would then be pumped into rubber oil bags, which would then fall off automatically once it is full. As for the seawater that were left after the separation process, a second filtration would be used to release clean water back into the ocean. The air layer of the oil bags in Figure 5 ensures them to float on ocean surface.
Given the characteristics and advantages of our design, the next question lays on how we should bring our ideas into practice and make our plan practical. Our main strategy is to make separating oil and water as immediately after the oil spill occurrence as possible by having multiple little ships to work together at the same time. The packaging machines will be continuously separating oil from water and package waste oil into rubber bags, and other ships will be in charge of towing rubber bags away. Therefore, many ships are required for our process, and which can be achieved by building a shared economy system in which multiple ships work together. To achieve this, we hope to cooperate with governmental organizations, and the government would help us to create a fund by practicing stricter oil spill taxes. Corporations with high oil spill risks want to avoid getting taxed extra or to pay the government for cleanup processes, and thus would be willing to hire cleanup ships to help clean up the oil. Cleanup ships with our equipment would then be in charge of separating the oil from water and leave rubber bags on the sea surface. After many rubber oil bags are made and released, nearby fishing boats or other kinds of ship could help tug them away and send them back to on-land stations or oil refinery company, and they would receive a reward for each bag of oil cleaned from the fund created by the government. With the model described in the previous slide, here's what's going to happen when every stakeholders are present. An oil spill occurs in the middle of the sea. Then the organization that caused the spill would contact cleanup companies that have purchased our apparatus. Cleanup ships would arrive at occurrence shortly after, separating oil, making waste oil bags, and leave them on the sea surface. Finally, nearby ships will be informed of the location of rubber bags equipped with RFID chips and go tug them away and send them back on land. Data science and the internet will also be critical to our plan. We will create an app that notifies users, which are usually individual ship owners, about rubber bags to be collected near their location. The information of oil spill occurrences will also be recorded and analyzed to prevent future oil spills. For instance, data showing a certain area that has frequent oil spills may indicate a specific problem in the oil platform, leading to future preventions of such problems. Our design is also flexible to be applied on different usages. For instance, it can be placed in ports as regular stations to clean up oil pollution caused by ships entering or leaving the port, or be equipped directly on ships that spills oil frequently to prevent pollution at its start. Moreover, it can also be equipped on drain pipes of restaurants or factories to filter oily water and prevent them from discharging into rivers or oceans.
As oil spills worsen through time, it is certainly one of the most imminent sustainability problems in the world. One of the 17 Sustainable Development Goals set by the United Nations concerns life below water, which is what our proposal primarily addresses on, especially on several targets of this goal. Target 14.1 aims to reduce marine pollution. Our proposal achieves this by providing a new process of oil spill responses, making it more efficient without creating negative side effects. By the same token, Target 14.2, which is protect and restore ecosystems, is also achieved since marine ecosystems would be well protected if oil responses are immediate. Most importantly, the core value of our proposal connects Target 14.7, increase the economic benefits from sustainable use of marine resources. Our proposal achieves this by building a shared economic system which multiple stakeholders are profited by participating in oil responses. With our plan in line with many aspects of the 14th Sustainable Development Goal, we believe that our plan is on the right track of reaching sustainability for marine resources and lives. Our expected effects have 3 stages going from short-term to long-term. The first stage is to improve the flaws in current oil spill cleaning method, which is first, not fast enough, and second, material consuming. Stage 2, which is Horizon 2 on the graph, focus on 3 main points. One is externality internalization, using our original system to largely minimize oil spills' harm to the ocean. 2 is to use big data collected from the app to calculate the risk and frequency of oil spill incidents in different areas. 3 is to improve the environment and ecosystem of polluted areas. When it comes to Horizon 3, which is many years after the project started, we wish to establish few main goals. Set precedent for government's use of award system on environmental issues, wider use of shared economy model, and raise awareness of marine environmental conservation, and further, raise awareness on other related topics. This is our reference page, and thank you for listening.
The team gave us clear introduction about oil spill incident in Taiwan. Also clearly list the comparison between OPA versus traditional oil tanks and OPA versus sponges. I still have two questions I want to ask the team. First, it seems that many groups of your OPA are required to go into the water to collect oil. How do we know how many OPA should be used? Second, in the concept, it is more like the OPA will be used on the land. Is it correct? The OPA only used in the sea or not? Please clarify this for us. Thank you.
Here I have two minor questions for you, for the team. The first one is that your proposal mentioned oil packaged apparatus try to separate oil from the water as a way to clean oil pollution. But to my understanding, separating oil from the water is a quite established technology and established tool to be used to clean to reduce the oil pollution. So what would be the innovative features or positive sides, positive points of your device that traditional devices cannot achieve? This is the first question. And the second question is that your proposal mentioned you try to commercialize this device and incorporate it into the shared economy. Here, I do not quite understand what you mean by shared economy. Would you please specify more? Thank you.
My question is that the oil-water separation is the current treatment method during oil pollution incident. Do you compare your method and the current treatment equipment? It would be interesting to compare the performance of your proposal and the current treatment option. The second, do you plan to compare the cost difference between your proposal and the current treatment option? Please explain.
Okay, to me, for high school students to propose the idea of oil packaging apparatus, I have to say I'm really very surprised because this is a very specialized issue. So I have two questions for you. Number one is actually similar to Dr. Chen. I do not really understand what you mean by quote, shared benefit model, unquote. Please describe the novel innovation and business model which comes from your team and are not available in the market. So just explain why you say this is a shared benefit model. Number two, in your presentation, you pointed out to implement the benefits, you wish to cooperate with the government. And why you want to cooperate with the government? Why not create a business model and write an implementation plan and then raise funds from the private sectors? You know, private sectors are richer than the government. Thank you.
I think the idea in your proposal is very interesting. But did you compare the commercial available product? What's the advantage of this of your device? And is there any other prototype you have tried? And the second question is after the oil packed, what will you treat them? Make your device is more spatial. Thank you.
Okay, for the first question, how many apparatus have to be there to clean up a oil spill occurrence? Our answer to this question is that we are currently unsure about this because each oil occurrence is not there's not a certain amount of oil spill in every oil spill occurrence, and this is also the advantage of our method, because in traditional oil cleanup ships, it's like a certain amount of volume there, and they have a tank that is that is limited to a certain amount. But our apparatus doesn't have this limitation, so we just have to have to have enough amount of apparatus to clean up the oil respectively to according to the oil spill occurrence. And for the second question, our current solution is that opiate is currently only used on the sea because they have to be there to clean up, to collect oil and separate them from water. And the third question is about how are we different from the current method? And as the professor said, we use the current method of separating oil and water, which is centrifugal separation. And we think our best innovation from current methods is that we separate the process of collecting oil and storing them, which is a very, very severe problem in this current methods because they lack efficiency when you have to collect all the oil and fill up the tank. And once you fill all your like tank volume, you have to return. But we don't have this problem. And by doing so, we increase our efficiency by a lot. And also we have this, we have one on mobility and persistence and effectiveness over the traditional methods. And we won on mobility because the physical appearance of the apparatus makes them able to move faster and thus decreasing the time needed to travel to the oil spill sites. And we win on persistent because while it takes traditional cleanup ships days to arrive at an oil spill, our apparatus is light enough that we can arrive them very fast, and even we can transport them through helicopters, which is very convenient. And while our apparatus can continuously separate oil from water and does not have to return when it is filled because we have these separable oil bags, we can also increase like our persistence in terms of we can continuously separate oil from water, which traditional cleanup ships cannot do. And effectiveness is just what I mentioned. And for the fourth question about the whole shared economy system, we think that this is what we didn't make very clear in our project, but I think our concept is there because the whole concept of shared economy system is that traditionally the corporation that spilled oil has to pay for the whole cleanup process, and they have to pay for the government to help them clean this up. And our method is not one single organization in charge of cleaning up all the oil, but instead there could be multiple ships from multiple different owners, and they are able to clean up a portion of spilled oil. But once shared, not only are they able to clean up oil in a more efficient manner because then we now have a lot of people cleaning them up at the same time, but they will also be able to gain some revenue from it, which is why we say this is a shared economy system because everyone gains something from it. And as for why we want to cooperate with the government, we think that it is because government is more impactful, and they have this. Because what we see is very important in our proposal is that the government has to be present to make our ideas more common to the people. And by having the government helping our proposal, they can be there to just coercively force others to join this and make.
Thank you to Team Ocean Savers for their presentation. Next, please welcome Team FIPA from Kanchao International School with their proposal entitled Finding Marine Drifts Near Taiwan Shoreline Using Drones and Machine Learning.
Hello everyone, my name is Doris.
My name is Shan. We're really honored to have all of you here today. We're students from Kanchao International School and currently studying in grade 10.
Today, we are going to introduce our proposal, FIPA. In this presentation, we are going to separate the proposal into 7 sections. This is our table of content. It is going to cover from motivation, to invention.
The motivation we're so passionate about tracking plastic waste entering the ocean has to do with our experience traveling to the Maui shoreline. In our acknowledgement, the beach is always clean and pure, but this is not the case. While we were there, we witnessed trash everywhere on the beach. The scene has blown our minds. We started to research and learn more about the polluted ocean. The statistics has raised our attention on this issue to a whole new level. For instance, there are about 4 to 12 millions of tons of plastic entering the ocean annually, which is meaning that every minute passing by, one garbage truck of plastic is being dumped. In recent years, most people have a certain understanding of the ocean. We knew there was a lot of drifting trash floating around, and the trash would often be picked up on the coast. But have you ever wondered where are these marine debris coming from? And why is there an incomplete collection of marine debris every year? Doris and I were very curious about the question, so we started our investigation on this topic.
As we investigate further, we discovered that due to Taiwan's unique relationship with ocean current, marine debris is actually stuck and blocked. This means that the drifting debris will create and stay in our current and prevent it from floating out, while external drifting debris can be easily caught and cause more drifting debris to stay in our current. According to Ocean Rescue Organization, the marine debris we see on our shore is only a tiny fraction, with less than a quarter of all marine debris washed up each year. This means no matter how innovative the environmental groups are trying to collect the marine debris, they can only see on shore. 3/4 of marine debris is still floating in the ocean, which is why we see so much marine debris wash up each year. Therefore, we plan to investigate the distribution of marine debris in the sea area to make it easier to collect.
In a state of brainstorming, we combined some personal experiences to create our solution.
For me, I have experiences flying drone. I am also very interested in this field and hope one day I could take an exam and get a professional certificate. I also have a drone that I bought when I'm about 9 years old.
As for me, I'm more interested in the coding field. I've been learning basic programming since grade 5, and I have tried C language and Python before.
So we came up with a proposal, FIPA.
FIPA. The word FIPA stands for Fly, Identify, Predict, and Apply. Using drones, we want to fly over the coastline of Taiwan, identifying the plastic debris using the comparison of infrared rays. Inputting these data into a machine learning program, we can then apply these predictions into existing machines. As a result, we wish to have a chance to implement our idea and hope that people can contribute to the ocean.
First, F stands for Fly. This is the first step of FIPA plan. We want to combine drone and infrared detectors and fly it to the coast of Taiwan, especially the coast of Hualien and Taitung, because according to the past data, the coasts there are most common with sea drifting garbage. According to the seasonal change, we will collect the data in batches so that we can get the data of different seasons. And we choose to use drone instead of satellites for 3 main reasons. First of all, drones are more suitable for us to operate. And then, drone can conduct detailed survey in smaller area. Furthermore, compared to satellites, data from drone can be obtained more quickly. This part is mainly the raw data collection step.
Second, I stand for Identify. There are 2 types of infrared detectors, temperature and bend detection. We will use 2 methods. The first is a temperature sensor. The temperature sensor can sense living and non-living bodies through temperature. If we detect a large area of non-living organisms in the sea, we can judge that there is a chance that there will be a large amount of marine drifting garbage. Next is the bend detector. Using the wavelength, we can judge whether there is garbage drifting in the sea because the fish usually have a certain distance from the water surface. If this wavelength hits the object very quickly, we can judge whether there is garbage drifting in the sea. The data that was collected will be compared 3 times, namely photographs seen by sight, IR data on shore, and IR raw data on the sea. We will do a simple experiment on the coast, collecting the bends of various garbage and compare the bends on the sea, and then use the original camera mode of a drone to take pictures of drifting garbage on the sea and compare the data with the photos. This part is mainly the collection and classify step.
Next, P stands for Predict. We will group and code the collected data and implement it into machine learning, which we will want the computer to tell which band or temperature have marine debris and which one are free from marine debris. In other words, implement one of machine learning. supervised learning, to tell the computer the corresponding value to provide the computer to judge the error used in the output. In this way, the computer can independently judge and predict the distribution area of marine debris. We will do multiple result comparison to achieve the highest precise. And to improve accuracy, we will hire a diver to go to Hawaii to do field work to ensure that our data are accurate. This part is mainly the producing result step.
Last, A stands for apply. After machine learning can successfully operate autonomously, we will cooperate with other NGOs to implement further innovation for collected plastics. In this way, the water near Taiwan can return to a clean state. Next, we will look for relative sea areas that can be used in conducting new research on them. This part is mainly the future collaboration step.
FIPA differs from other groups in 3 ways. First of all, it can be seen that from this picture that everyone usually clean up the marine debris on the beach. But what we want is to clean up the marine debris in the sea area. Furthermore, most of current methods of cleaning up marine debris are trawling. It is precisely because we do not know where the marine debris is distributed. We do trawling in a large area. FIPA can solve this problem. It can help to detect the distribution of sea drifting garbage and make garbage collection more efficient. In the end, we think that FIPA, efficiency scouting and collaborating with other teams can make more use of the founded trashes. Let the sea area have less drifting garbage.
After we present our plan, we did more data investigation and refinement, and now we would like to expand on further evaluation of FIPA. First, we combine infrared thermal detector with an infrared spectrometer in order to analyze infrared wavelengths, which is SPECT. According to the National Institute of Experimentation in Taiwan, infrared spectrometers are one of the most effective instruments for identifying organic and inorganic compounds, and band rays are especially suitable for functional group confirmation and molecular composition identification.
Furthermore, the detection energy range of the newly added infrared spectrometer is 4,000 to 200 cm -1, and the resolution is high, usually with 0.001 cm -1. We can conduct data survey on coastal debris, and it is easier to distinguish the energy range of the marine debris. Not only that, because obtained data is AD, analog to digital convert, the spectral results are easier to progress, and noise can be eliminated by combining the results of multiple stains to improve the signal-to-noise ratio, so we can obtain good and accurate spectral results.
Costs and supplies need to be separated into 3 parts: drones, field survey, and machine learning. All the costs are information suggested from internet, and most of the trial number need further consideration. We will be needing help from drone professionals, divers, and CS specialists. If we ever get a chance to proceed our plan, we will make the prototype first. As mentioned in the plan, some of the details need to be tried and made trials to ensure the quality of the results we received. Next, the pattern. If we can identify a pattern or mode the trash gathers, we can input it to other areas of the ocean. Then it brings us to the partner part of our envision. If this plan works out, a pattern is found that can be used globally. It is also essential for further cooperation to happen with other countries and NGOs. It is not just teams that gather plastic we need, but also the ones that can continue the research. Lastly, promotion. We want to bring this research results to the world. This part that it is different from partner is that this is a phase more aiming to spread the news. We want to start from the north coast of Taiwan, then to the whole coastal areas of Taiwan, and lastly, nearby countries.
Here's our citation, and we'll really like to make out our proposal. Again, we are really honored to be here today to talk to you all.
This is our presentation. Thank you. And we would like to start our Q&A session.
I like the team use a potato or a sweet potato as Taiwan. I feel that make video interesting. Using drone has recently been recognized as a possible method for marine debris surveys. So I want to ask, the first, which size of marine debris do you think that you could shoot? Second, Taiwan has many typhoons and rains and huge winds. So do you think are the foaming season and the marine debris accumulation season the same in Taiwan? Because it will affect your detection result. Thank you.
Here I have two questions for the team. The first one, which is quite similar to the one raised by Dr. Kerr. The first one is that I just wonder, you combine the unmanned vehicle with infrared, okay? So I just wonder what's the function or what's the function or the advantage of the combining the infrared used in detecting marine litter, and how high the device will fly, okay, such that it has enough resolution, okay, resolution to detect the marine debris. Okay, so I think this is very key. You need to answer in order to demonstrate the function of this device, or the feasibility of this function of this device. And the second is that the second question is that how this device can differentiate the objects between the former facilities at the sea and the marine debris. You know, because you use the unmanned vehicle with the infrared rays can monitor any subjects at the sea, but how you can differentiate, how the device can differentiate the novel facilities and versus the marine debris. Thank you.
Okay, in your proposal, you want to train the drone to identify plastic garbage. I want to know, in your opinion, how long does it take to train your drone to identify the plastic? The second question is, as your proposal's name, FIPA suggests, you want to predict and apply, but I barely see how you can predict. I do think the drone can identify the plastic, but prediction is another thing. Based on your method, I don't think you have enough data to make prediction. Can you respond to this comment? Thanks.
I'll have two minor questions for you. For number one, in fact, I'm a little bit confused by your proposal. Please describe what you have done, and what you are going to do. Okay, this is number one. And number two is in your budget plan, the part of drone needs 80,000 NT dollars. It's a huge part in your total budget. Please explain why you need this budget. Because in your proposal, you have pointed out that you had a high quality. So I don't know, I don't understand why you need a new one, or you need something. Please explain. Thank you.
The proposal is interesting. I'm wondering, you want to hire divers. So what's the reason you want to hire divers? And the cost for hire them, is it reasonable? And is there any other option, like you can have volunteers to do this work for you? Thank you.
Okay, so first of all, we want to thank all the teachers for their response. We understand that you believe that other solutions might be more effective, but then, well, they don't need so many trials and experiments. However, for example, for beach cleaning, but then have you noticed that every year continuously, people or organizations, they hold beach cleanups, however, the amount of plastic debris is not being decreased. So all we've done was like to wait at the beach and wait for trash to show up. So compared to our plan, we have the one that's more initiative. And since we have the chance to implement our plan, why do we wait for the others to find out our severance and not do it ourselves? The size of the marine debris should be determined by, of course, the range the drones can take the pictures, and we're going to compare it by using both the infrared data and then by our eyesight too. So we're going to identify the marine debris and put it into the machine learning before we let it predict the next results.
And the second one is that we understand that due to the rains and weathers or ocean observations, that the data will need many trials, but that ocean current has a large scale of directions and movement that won't change. So the data we found can be used without change over a long time period of times. For example, in the sweet potato simulator experiment, we made that even though the range or the ocean current change, the floating garbage in the sea can be also seen that they will gather in one of the places, and due to the ocean current will not change so easily, so that we can make sure that our simulator experiment has operate on the coast, and we can see that the data in the background can improve our probability of succeed.
And third of all, the function or advantage. So according to Taiwan's National Institute of Experimentation, there's a research, and then the infraspectrometer is one of the most effective instruments for identifying organic and inorganic compounds, especially for the confirmation of functional groups and the identification of the molecular composition of materials. So the detection energy range of the infraspectrometer is 4,000 to 200 cm-1 and has a high resolution, usually within pounds sterling, 0.001 cm-1. The drifting garbage and fishing nets are related to Taiwan's topography. Basically, that's why we chose to use infrared rays.
And flying on the ocean is approvable, but as long as the professional license and follow the rules. First, the flight speed does not exceed 160 km per hour. Second, the nearest 2 meters away, keep from the observation for 30 meters away. And the radius of the operator is 900 meters, and the height of the water surface can less than 400 feet. Not over that, the drone cannot fly after sunset or before sunrise to fixed point and not moving on a moving boat.
And how the device differentiate the facilities? So basically, we use machine learning, and as mentioned, we're going to use both supervised and unsupervised. So basically, we are going to tell the computer what is a plastic debris and what is not, and compare with the infrared array records. So that's the computer can use all these kind of reference to identify plastic.
And basically, we believe that without 2 years, which is to 2024, we can finish this whole project.
And we're going to separate into we're going to separate in seasons for the ocean current. Next is for predict and apply. So I mentioned supervised machine learning will need the input and output data. Therefore, we were going to use basic photo and data results, and we will inform the computer what is the plastic debris.
So as I said that we have drone, but we need a driver or a drone professional to help us to fly the drone, since that Taiwan regulations stated that we need lessons to fly the drone all over the sea, and then the payment are from comparison online, so that it might depend, but our time required is 3 to 4 hours, about 8 hours a day.
Next is cost and budget. So then we will be separated costs and supplies needed into 3 parts: the drone, the field survey, and the machine learning. So for drone, the cost is about 60,000, but then we already have a drone. All we need is the kit, what is about 20,000 NTD. And then we might not be needing unless the plans go broader. And the time required for using drone is about 3 to 5 trials, but consideration will still be needed. And the 1,050 NTD per hour for the divers and 1,500 NTD for drone professionals. These payments are from comparison online, so they also like to pay. And these are our answers, and thank you for your recommendations.
Thank you.
Thank you to Team FIPA for their presentation. Next, Team FGC from Morrison Academy Kaohsiung with their proposal entitled Transformation of Plastic Marine Debris.
Good afternoon, judges. We are FGC. What if we told you that you can save the environment by living in your own trash? I know that it sounds counterintuitive, but let us explain why this has to be the future. Marine debris is destructive. 8 million tons of plastic are being thrown into the ocean annually. And these plastics, due to long exposure of UV light from the sun and the weathering from the wind and the rain, these plastics are becoming microplastic particles, which are now classified as marine plastic snow. Marine plastic snow is a major contributor to marine biodiversity loss. Microorganisms will start to grow on the surface of plastics, and these items will look like food for the fish. And these microorganisms will also cause heavy pollutant and heavy metal to stick onto the plastics, which when the fish eats them, and then when we fish them and we eat the fish, we will also eat the heavy pollutant. So this is the composition of marine debris. 62.3% is plastics, 14.7% is fishery, 4.7% is styrofoam, 3% is glass, and 15.4% is other. And this is why we are focusing our solution on plastics. So the plastic production also greatly increased after 1970, and this is why. This is a problem that we gotta face.
So, a lot of people might think that raising awareness from the public and placing prohibitions on several products can solve this problem of plastic marine debris. But we believe that these are not the solutions that are viable. So let's think of an example of public awareness. So people are definitely aware of the harm that plastic bags cause. They go into the ocean, see animals, feed on them, and then it causes damage to the environment. Everyone knows that, but no one actually takes the time to decrease their plastic bag use. That's how awareness is not a key to this solution. The second one is prohibition. Prohibition also doesn't work because of public backlash. So an example would be the government's attempt to place a prohibition on plastic straws about 3 years ago. So from tea shops such as 50兰, they placed prohibitions preventing them from giving any plastic straws to customers. However, this only caused customer discontent and severe backlash from the public. And this caused a lot of the citizens to become discontent with the government, and it also wasn't an effective solution, as evident from the tea shops giving plastic straws now as well. So we believe that awareness and prohibition are not the solution to this problem. We believe that recycling and reusing the trash is the key solution to this problem.
So obviously, our solution is to reuse these plastics in order to create a product. And our product that we'll be creating is construction material for houses. So why are we choosing construction materials over everything else? Well, the first reason is creating these construction materials is actually the second largest source of carbon emissions. If we use our reusing plastic technology to create construction materials, we can actually not only decrease plastic waste, but we can also decrease carbon pollution. Furthermore, creating construction materials requires 40% of global energy. And by using our technology, we can decrease that amount significantly. Lastly, not only are we saving the seas by reusing these plastics that are in the seas, we can also save the environment, like the forests and all that, by creating construction materials, because construction materials not only require products that are harmful to nature, but it also creates side products that can destroy ecosystems.
So this is why WPCM is our solution. We will be creating construction materials like bricks, exterior tiles, and ceiling tiles.
So one of our main products to produce is bricks. The main reason why we want to produce bricks is because it brings several advantages over conventional bricks. The first one is that it's durable and reusable. So think of plastic. When you drop it, when you burn it, however you want to decompose it, it doesn't really break. And we want to use that to our advantage and use it as building blocks of apartments and other buildings. The second reason why we want to use plastic bricks is because it's fast to assemble. Since it's fast to assemble, we can use it during disaster relief to build houses quickly for the refugees that don't have homes. And then these are the major benefits of what we believe to be of plastic bricks.
Similar to what Simba has said, we want our exterior tiles to be more durable and wear-proof. Furthermore, although it doesn't seem to be very important, we actually create different colors through these different plastics because we can use various plastics which have various colors and create into construction material to improve aesthetics. Although this technology is slightly more expensive, we are paying 5% more in order to improve society.
So lastly, we will be creating ceiling tiles. And why ceiling tiles? It's because in Taiwan, a lot of local school and business buildings all use ceiling tiles. So this is another place for us to use up the plastics in the ocean. And the same reason as previous products, plastic is durable, which means our ceiling tile can also be super durable. And aside from the fact that it's durable, it can also help trap heat. Plastic ceiling can help trap heat and keeping the heat within the house, lowering temperature fluctuation, and helping to save electricity during winter. And during summer, these plastic ceiling tiles reduce heat from external sources, saving cooling costs in the season when energy is in high demand. And plastic ceiling also have the ability to be soundproof. And then the last benefit is that it's also fireproof, because we will be creating the plastic ceiling with PE. PE has a very high melting point and it resists combustion, which all these advantages bring us to the solution that we want to create bricks, exterior tiles, and also ceiling tiles. So the manufacturing process for our product is collecting plastics, and then we bring these plastics to a recycling plant, which people sort out different plastics because not all plastic can be heated up together because they have different heating melting point. And then later on, plastic will be pressurized and heated, and then molded into different products, and then we will have durability and sustainability tests to ensure our customer that it's safe.
So this is our budget table, which includes all the money that we might need to spend when we actually execute this plan. So the main categories are employing staff, collecting the plastics, building the factories, having an office for the workers to work in, and then advertising our company and other miscellaneous costs. These can be used during accidents or emergency events where we need money.
In order to make this product reality, we're going to go through a 3-phase plan. Okay, in phase 1, we'll begin by advertising in hopes of gaining funds and gaining public attention. This will allow us to raise awareness while attracting partnerships and other organizations. And through gaining funds, we'll be able to research and improve our product. And we'll use model houses to prototype and explain how it works. And this will help us market and showcase how effective our product is. And in phase 2, we'll finally start up the factories and gain even more connections so that hopefully one day we can be independent and not rely on other organizations. And in phase 3, finally, we'll gain independence and have enough funds to sustain our company. And then we'll have recycling stations so more people can gather trash and for us to make products. And then we can expand our partnerships to like other organizations who have the same goals as us, which is to raise awareness and decrease the environmental damage that humans cause.
So after our company is fully developed, we will have computer services, which we will go to third world country and then collect trashes from slums and places, and then transfer those trash into our products, which we're basically transferring where they live into a better place because we are collecting trash and then making them into our products and then building them houses with these kind of products, which is what we are here for because we need to help the people. So please invest in us. You're not just investing in us, but you're investing for a prettier Earth, further than what it is now, and investing in a practical solution for us to stop this problem before it's irreplaceable. Join us on this journey. With your support, you can help us start building a brighter future. So if you have any questions, contact us. Thank you.
Thank you. I like your creativities for using the reused plastic for construction materials. But I have 2 questions for you. First, because this reused plastic would be a construct materials, how about the strengths, especially those being used as external tires? Second, the ceiling does look very beautiful. How about cost during the processing to deal with the reused plastic as the ceiling? If the unit price is too high, it may be difficult to further promote and use that as the construction materials. Thank you.
Here I have 2 minor questions for the team. The first one is that in this proposal, you try to establish a company to deal with the waste plastic and convert them into the commercial goods for making profits. But I just wonder, do you have any financial feasibility analysis, or financial feasibility analysis of this of operating this company? And just please specify it. And the second question is that we know that there should be a constant supply of inputs or raw materials for the operation of a company. So I just wonder, do you have any idea on securing a constant supply of waste plastics? Okay, which are to be used, utilized by the company. Thank you.
Okay, there's a lot of way to recycle the plastic, such as making them sport t-shirt and stuff. In your proposal, you want to recycle them as construction material. Is there any special reason for that? Oh, that's the first question. The second is, your company seems to be very ambitious. You have your own plastic collection team, factory for technology development. You have your own marketing and advertisement, and you want to prevent the garbage entering the ocean. That's a lot of work to do. What if you can only focus your effort to do one task? What will it be? Please explain.
Okay, I have one minor questions for you. The idea of recycled plastic bricks, plastic ceiling tiles, and the plastic house is actually not new. Would you please explain the difference between your idea and the technology from those available on the market or on the websites? What are the new innovations from you? Thank you.
The idea is interesting, but in your proposal, I didn't see the timeline for conduct this plan. Could you explain? And what's the total amount of the budget based on the timeline of this project, and how to use it efficiently? Thank you.
Okay, so for the first question, Ms. Cole asked that reused plastic will be construction materials. What about the strength? So for our presentation, we did explain how our plastic brick is being tested for the strength of the materials. And when we tested it, the bricks, when we drop a brick from a 10-story high building, the brick will break, but the plastic won't, because the plastic is more.
So in comparison, the regular brick that we use is actually a lot weaker than the plastic bricks that this process would produce.
And another question is that.
Okay, so, and I think you guys are also talking about the durability of the building itself when you use reused plastics, because although the plastic itself may not break, the building may collapse because it is less durable. But that is not a problem, because although we aren't using any bricks that we normally use, we will still have to use we will still have to abide by the regulations of creating buildings, and that will allow us to simply change the material into plastics, but not sacrifice any durability of the buildings.
Yes. And the second question is that building looks beautiful, but what about the cost? If the unit price is too high, it may be difficult for promoting plastic as construction materials. So we did a case study, and then I went out and asked 5 companies, and 4 of the 5 companies agreed that they believe that because this can help the environment, they are willing to pay the money. So, and another trend in Taiwan is that if companies start to implement something that the other company that don't have, then they will follow in. So for example, if a building company start using our products and they figure out that this is a plan that is doable, then all other companies will join in to use this kind of products. So it's kind of
win-win situation.
Yeah, it's a win-win situation. And then the next question is that establish a company to deal with plastic waste and convert it into commercial goods. Wonder about financial feasibility. So in our presentation, we also talked about how we will team up with other companies outside to support us with the plan.
And then because plastic is like such a huge waste source, it's really easy to get the materials that we need to build our like company. So in order to get our company bigger by collecting the materials, we aren't really spending any money at all, because it's just waste that people don't want.
And we also know that other companies will want to establish a connection with our company or like work with our company, because a lot of companies are using the idea of no waste into their advertisements, and only with working with us or working with other recycling companies will they be able to achieve this name. And with that name, they can reach out to more customers, which will further increase their profit.
Yeah, and also the thing is that we understand that the waste in the ocean, although isn't unlimited, it feels very much so right now. And the fact that when we reach the time where it feels limited, that's at the point where we basically achieved our goal of protecting the environment.
And the next question is that how can we gain constant supply? So our presentation did talk about how we will set up plastic collection centers around Taiwan, and then we will also put like recycle bins all around tourist sites to collect plastics from people. It's way faster to collect plastics from people than to collect from the ocean. So that if we can stop everyone from throwing away all these plastics into the ocean, then it's good. And there's always constant supply.
Now, this question connects with the other question on what will we focus on if we focus only on one aspect of our plan. Our main goal is to use the plastics in a certain way where people will continue using it. So our main aspect that we'll be focusing on is to create the plastic bricks for construction materials, because in that way, we can work with other companies in order to collect reusable plastic. We can work with architectural companies in order to buy our plastic bricks. And we don't need to do any of that, but we are still protecting the environment by reusing that plastic and creating it into plastic bricks. So that will be the aspect we will be focusing on if we are unable to do the rest.
And the fact that we are eco-friendly kind of makes us more desirable towards the companies that would want to work with us.
And another question is that what is the special reason for converting into construction materials? It's because if there's humans, then we need houses. And so then it means that there's.
Thank you to the team FGC for their presentation. Now please welcome Team the Terminator of Marine Disregarded Face Masks from Kaohsiung Municipal Ruixiang High School with their proposal entitled Action Plan for the Marine Pollution Crisis Caused by the Masks and its Solutions During the Pandemic in Taiwan.
Hello, everyone. Today, I would like to talk to you about our project, Master Ocean Pollution Crisis and Solution During the Pandemic in Taiwan. The project participants include 吕世峰、严永爱、简品瑞、康义云、孙玉文。This presentation will focus on the following key points. Marine situation. More and more people wear masks due to the outbreak of COVID-19. What is still worse is that the used masks are later without proper recycling. They will flow into the ocean and then pollute the ocean. Ocean Asia, an international environmental protection organization, estimated that about 1.56 billion masks flowed into the ocean last year, equal to thousands of tons of plastic pollution. Why do used masks pollute the ocean? First, medical masks are produced and used greatly during the pandemic, but the discarded masks are thrown away carelessly and cause pollution. What's worse, increasing global mass production and consumption has done harm to the environment. Disposable masks are mainly made from disposable plastic and have a negative effect on marine ecology. Our team's goal is meant to avoid discarded masks flowing into the ocean. The following are the government's regulation and the policy related to discarding masks. First of all, the authority issued regulation about plans to ban littering masks, but the fines are difficult to prevent people from throwing away masks. In addition, government has set up mass trash cans in public places. However, their lack of management and design made the effort in vain. Therefore, we would like to make an efficient mask recycling bin.
Second, problem analysis. With the outbreak of pandemic in Taiwan, if masks are discarded without proper recycling and end up in the ocean, they will be easily eaten by marine organisms and pollute the ocean as well. Even though the government has set relevant regulations, they are not effective. 1. The difficulties of implementation. Although the government has set the relevant penalties, there is not enough manpower to enforce the law. The public need to spontaneously report. 2. Establishment and management of mask recycling bins. As of March 2020, a total of 428 mask recycling bins have been set up in public places across Taiwan, but their flows is not tracked, creating another pollution risk. No mask recycling system in Taiwan, high processing costs, and its difficulty of creating economic benefit are big issues. 3. High cost of mask recycling. Polypropylene, PP, is the most important source of plastic pollution, and it takes at least 400 to 500 years for these materials to decompose naturally in masks. Therefore, decomposition and recycling are not easy but costly. 4. The concept of mask recycling is not clear. The public doesn't understand the classification of masks, and discarded masks can easily cause pollution. Third, motivation. Since the concept of mask recycling isn't popular and the pressure on both government and private enterprises is large, we decided to promote mask recycling bins and expand their functions to prevent environmental pollution.
Fourth, improvement and solutions. The following is an introduction to the functions of our mask recycling bin. In order to attract people to actively recycle masks, the mask recycling bin has added music feedback functions. In addition, it also has an alcohol disinfection machine and a temperature measurement function, so that the mask recycling bin is not just a recycling bucket.
5. Strategies. Promotion of mass recycling bins. How do we design a mass recycling bins? To attract children and parents to recycle masks together, the mass recycling bins design automated equipment and innovative music keyboard service. Promote and set up a mass recycling bins. Firstly, we will use social media platforms such as Facebook, YouTube, Instagram, Twitter to promote our mass recycling bins. Secondly, we will contact with school, convenience store, pharmacies, and village community office to make people know us more. Lastly, we will cooperate with organizations to hold a campaign. For example, Taiwan Association of Marine Environmental Education Promotion Association is an organization to protecting the ocean. By cooperating with them, we are able to achieve the goal. 6. Teamwork. Our teamwork is separated into 4 groups, and there are 2 members in each group. 吕世峰, Kang Yiyun. They are the leader of the group. They plan and organize the group. 简品瑞, Sun Yuwen. They contact the expert and manufacturer and monitor the manufacturing process until it has done. 严永爱康义云 They make the plan for promotion and choose where these mass recycling bins are placed. 吕世峰孙玉文 They control income and expenditure and make sure we don't overuse the money.
7. Work period. The following is our teamwork period Gantt chart, including purpose program, design mass recycling bin, mechanical relax expert consultation, contact manufacturer, mass recycling bin setup, promote mass recycling bin, mass recycling bin use result acceptance. 8. Funding. The following is our project financial planning. In addition, funding is mainly based on machine design and price information is obtained from internet information. The total of the funding is $72,100. Music function can appeal to the parent and the children to recycle the mask. We also promote the mass recycling bin by cooperating with government and civil society to increase popularity. That the public are willing to participate in these green activities. By doing so, we can reduce the marine pollution of masks. Thank you for your listening.
It's great that the team can find a current environmental issue and try to solve it immediately. However, I have 2 questions for you. First, which location do you plan to put? Second, I found that you design alcohol disinfection place, but how about for this design? So, do you think you will that the people who put the mask into the bin to use alcohol disinfection, or the people who try to clean this bin? And how about the time frequency that you will go to clean the recycle mask bin? Because I'm also wondering if this mass recycling bin will become another place to spread virus. Thank you.
I'm glad to see that the team identified the mask littering problem and try to solve this problem. Here I have 2 minor questions. The first one is that it seems to me the proposal, or we say the mask collection bin, just serves the function of collecting the waste mask. But I'm concerned about the hygiene problem, okay? So how this device can prevent the spread of viruses, okay, cause the spread of viruses if people throw the mask into the bin. I'm just concerned if the people will be contaminated, will be infected with the virus left in the bin. This is the first question. And the second question, I also wonder, when the masks are collected in the bin, how you to deal with this waste? Do you just throw them in the garbage by burning them out, or any ways to recycle them? Please specify more on this. Thank you.
Okay, I think your proposal is very interesting. That I also think that the installation of a recycling bin should alleviate the current littering problem of the mask. But I do think that the proposal should describe the use of the mask as after it was recycled. What's the use for that? The second question is the mask has hygienic product and then may have pathogen concern. How do you make sure you can disinfect the mask for safety reuse? That's the question.
I'm quite happy that our young generation follows the topical issues. with interest and concern. Through the presentation, the team focuses on the design of the recycling bin for discarded masks. I have two questions for you. Number one, could you please explain the idea behind the appearance design of the recycling bins? Okay. Number two, it is good to recycle discarded masks. However, you also point out that the recycling cost is high. So, in addition to encouraging people to drop masks in the specially designed bins, what else you can do to increase the recycling rate? Thank you.
I think this proposal is very good. My major question is you only want to make one mask recycling bin. Is it enough? So if someone want to donate more funding to you, how many the bin you think is good? And where do you want to deploy these bins? The priority of the area, could you propose and explain what's the reason you choose this area? Thank you.
First of all, when it comes to the location of the recycling bin, we think the park is the best place to put the recycling bin because there was a lot of children and parents going to their hangout or for something else. They could go there and recycle their mask. So I think park or some leisure place to put the recycling bin is the best alternative.
About the question of alcohol disinfection functions, we want to let the people who want to recycle, especially the kids, they can use the alcohol recycling disinfection because after they throw the waste, they have to use the alcohol disinfection functions. Yeah.
For question how to make the recycling after they throw the mask into the recycling bins. When we research for some study with news in the abroad, they have to make the face masks to become like chair or other things in our daily life. But in Taiwan, there's not a very good recycling systems to make the face masks to become less things. So maybe we can try to commend the government or other companies to do this project in the future.
For question how do we design the best recycling bins? Because because we see a lot of masks were discarded at the beach or road or somewhere, and we think it's needed to recycle the mask into bins or so we design these best recycling bins.
I think the one recycling bin is not enough because of the funding is not enough to put more recycling bin. But when in the future some mass manufacturer would like to invest in our project, we think we will launch an investment and put a warning on their master party to call for people to
recycling their mass in our recycling bin. And with this, they can use their investment in our recycling bin project to prove more recycling bin in the part or something else to make more people to join this project and make more people to would like to enjoy this project.
About the question, how we can do after recycle those fast masks, we will use the fast masks as the filter of sofa or the door stood because in the things recycling we can just burn it. I think that's not a good way to after we recycle those fast masks. About the question about how many recycling bins we have to make, now we just want to do the test about how the recycling.
Thank you to the team, the Terminator of Marine Discarded Face Masks for their presentations. Next, please welcome Team Environmental Recovery Organizations from Kaohsiung Municipal Kaohsiung Senior High School with their proposal entitled Floating Republic.
And today we're going to present our presentation for the 2022 Ocean Challenge. Since the Industrial Revolution in the 18th century, fossil fuels such as coal and oil have been greatly employed as sources of power for machines. However, when people burn these fuels for energy, they simultaneously release greenhouse gases into the atmosphere. These gases prevent heat from escaping to outer space and as well makes Earth resemble a greenhouse, resulting in the elevation of average surface temperature above what it would be in the absence of greenhouse gases. As a part of the Earth, we're facing problems that cannot be ignored, one of which would be the rising of sea level. It has been rising since the beginning of the 20th century and has made the environment more unlivable for human beings. Another problem will be climate refugees. A plan searching for a livable space is imperative to accommodate the current and incoming refugees. There's also flooding, striking more and more frequently and violently around the globe. Lastly, as far as the marine resources are concerned, the dilated human population needs food, most of which comes from the ocean. The heavy reliance on marine resources has depleted the fish, such as tuna and salmon. To alleviate those serious problems, our goals are not only to find a place that can accommodate the current and future refugees, but also to combat the depleted marine resources and the subsequent rising sea level. First thing first, we figure out our lands are being diverted, while sea rising can't be stopped immediately. Simultaneously, the need for ocean resources is still rising, while the marine resources offshore are almost depleted. After thorough discussion, the thought of building cities on the ocean is likely to solve most problems. Adding a concept of floating house, we call our plan Floating Republic. Floating house and floating house committee. To make the floating house function properly, come up with a few kinds of materials to build up the floating house that may be able to meet our expectations. The first material that came up in our mind is wood, due to its light weight followed by low density. It may be a considerable choice. However, because of the high humidity on the water, wood must be thoroughly coated and treated against humidity in the long run. With the stable and tough structure brought by steel, floating house could gain high sustainability, which makes steel one of our potential choices. Nevertheless, steel have similar problems with wood. It must be treated against water corrosion regularly, using waterproof tanks and sealers. In conclusion, flotation pillars are concrete structures filled with extended colostrum. It can keep the structure stable and minimize collapsing hazards and humidity infiltration to the house. Also, according to research, floating pillars are suitable in both fresh and salt water. Moreover, it is also durable in seawater, which may reduce the cost of repair in the future. In conclusion, we decided to use flotation pillars as our main material to build the floating house. And now moving on to the structure. The two pictures below are the ideal model for our floating house. On the rooftop of the floating house will be beacon lights, with the side pointing to the west will shine red light, while the east will shine green, and the south will shine white. This is the basic aviation and marine principle used in real life in order to determine the direction and to prevent accidental crashes onto each other. Through the assistance of a GPS system, it is easy to locate the exact position of the bubble house. At the same time, detect the speed and the sailing direction of the house. Around the wall of the house are two windows. The ventilators and two windows allow the air to flow in and out. And also due to the height, the house located on the sea, the inside would stay cooler. In order to keep the air fresh, the first floor will have a bathroom and a kitchen. Remember, the bubble house is designed for war or climate refugees, and so it is expected that the house could be equipped with a complete house facility and amenity. The second level would be a living room, a window embedded on the wall or as a window of view. The third level is a bedroom without a partition. The staircase is installed to facilitate the movement among different levels. Floating houses are embedded into the floating board. The construction work will be expected as a level block. We assemble the parts after the structure of the house and board are built in the factory. In this way, the construction will be much easier, and the assembly work will go much faster to live up to the need of the increasing number of refugees. The idea of the floating house community derived from the drinking period. We hope the bubble house will not be a lonely planet, but groups of houses to form a marine community. The platform was embedded with floating houses. In this way, there is little worry about waves or currents. The residents in a unit can interact with each other, which might reduce the loneliness of sea life. A platform could accommodate many floating houses. That is what we call a floating house community. A number of communities will form a sea farm, which they manage. To find an ideal place to establish the floating republic, we decided to compare the pictures below. According to the charts above, we consider the floating republic to be established in regions that are vulnerable to sea level rise, dense population, refugee settlement capacities, etc. Therefore, the Caribbean Islands and South Pacific Island republics are the ones that would be most likely to be installed with the floating republic instrument. In addition, we anticipate implementing our proposal to the Republic of China, Taiwan's diplomatic allies, such as but not limited to Haiti, St. Vincent and the Grenadines, Nauru and Tuvalu, allowing for a Haiti and Nauru's dense population and the maintenance of rising sea level. The floating republic would be a feasible option to resolve the predicaments in the aforementioned nations. The environmental crisis, especially the possibility of the sea covering islands, St. Vincent and Tuvalu is also a key attribute when installing our proposal, since the changes of the sea level would severely impact the welfare of civilians. The routine invasion of tropical cyclones should also be taken into account. Therefore, we prefer the floating republic to be built in Haiti over other countries. For the concerns of Haiti's recovery from the Great Earthquake and the geographic circumstances of the nation, we are very much looking forward to cooperation of the Ministry of Foreign Affairs and the Haiti government with a view to assisting the citizens to find a safe place to live.
As for the power source, we plan to install a water pump underneath the floating house to generate electricity. This is a relatively efficient and environmentally friendly apparatus as a result of taking sustainability into consideration. This water pump, along with the solar panel on the rooftop, will provide essential power support to the building. Sea farm. The bubble house will form a community with their own way of self-sufficient life mode to reduce reliance on the land-based international community. Floating houses communities will be established and also have their own industry, sea farms. Sea farms will be running in the ocean community in order to raise sea creature resources. And additionally, a greenhouse may be built to breed vegetables that can be grown without soil under the hydroponic system. To combine the hydroponic system with a sea farm, desalination plants must be implemented. By hydroponic system requires reserve osmosis water to start with a blank slate and add precise levels for nutrients, promoters, and pH adjusters to the water, ensuring that plants are only absorbing proper nutrients dissolved in the water of the highest purity. Meeting the expected harvest. The sea farm has its ultimate water supply. Seawater has to be desalinated before using. Constructing desalination plants on the bubble republic will also provide daily water supplies to all the growers. Speaking of the environment, some folks might be concerned whether the floating house community will destroy marine ecology and resources. In reality, they can cultivate a multitude of new novel marine resources for house communities to take in, because the end aims to resident self-sufficiency instead of goading the marine creatures. Additionally, culture can help the ease of catastrophe human beings have caused, since the marine animals and sea branches are particularly mussel, salmon, and shrimp, which can conducive to sustain seafood for humanity. Mussels and kelp. The marine creatures are restricted to environmentally friendly species. Mussels are an exceptional species which have no need for antibiotics and foods. More specifically, no need to utilize pesticides or other toxic chemicals to breed them. Besides, they are found to take places to live, saving spaces for other different creatures to move around. And most surprisingly, they can filter up to 50 gallon amounts of seawater per day per one mussel. Not merely the mussels can do that, kelp and algae can do so as well. Kelp, on the other hand, is able to ease some issues such as dead zones. The serious condition occurs in the Mexican Gulf or Baltic Sea. The removal of such a zone can consequently bring back to us a wonderful world. In addition, the great antiquity plants can absorb excessive nutrients for the water body. The waste of the kelps is also able to become the nutrients for the terrestrial plants, forming a food chain benefiting our environments. To reach sustainability, what we should do is to make farm-raised creatures to possess brands in the markets. The brands can bring in profits so that funds used in the construction of the bubble house could be raised without taking up a huge governmental budget. If we farm brands and invite celebrities, we can possibly meet our goal, transforming our current circumstances. It is undeniable that the garbage waste will be dumped in a landfill. Therefore, all objects or items will be printed with a barcode or a QR code so that they can be sustainably recycled.
For implementations, we first build a model of a floating house. After the floating house be completed by construction, we test how wave and currents impact a floating house. Moreover, we ask the research center to computerize and to simulate how the wave and currents can impact the floating house. Populism prompts more and more people to look inward to their own problems and issues, which can be proved by the withdrawing globalization. Living in this modern era, we're currently faced with loads of issues, prompting us to figure out some solutions to combat the present perilous circumstance and make a transformation in every field. Precisely, we need to make differences in different aspects of ocean cities. As for us, a group of teenagers worrying about the internationally and locally environmental issues have come up with responses toward the problem, confidently hoping that we can make contributions to the future of our offspring and most vitally to our mother nature.
I want to encourage this team because they are the only team who focus on the sea level rise. And also they try to visualize their concept and for us to help us to easily understanding their idea. However, I have two questions I want to ask the team. First, the project is the concept of a family underwater, but Taiwan faces typhoons and earthquakes. There will be many constraints. I suggest that the team should propose challenges and corresponding possible solutions in the project. Second, when does this city type need to be developed? I mean, if Taiwan is a possible corresponding port, will the areas in Taiwan? And what is the queue and threshold that we should develop this kind of the city? Thank you.
It seems to me that building a floating community on the sea is like a good wonderland or utopia, okay? And as a way to deal with the sea level rising problem. But here I have two minor questions. The first one is that what would be the idea or the ideal places to place this community? Okay, I think you need to specify more on the condition of the water environment that is suitable to accommodate this community or set infrastructure. And the second question is that if this community is off grid or not. Okay, if yes, if off grid, then what would be the source of the energy? Okay, and if not, okay, you need to. It means that if not, then it means that the community should be connected to the lines at the land. So how you do it? Thank you.
Okay. The first question is that the floating house is a project that has been conceived abroad, and I think it's feasible to use model to explore the impact of marine weather on it. But the weather model requires a very sophisticated science, such as physical oceanography model to do the simulation. I wonder if your team are capable of doing this. The second question, you want to build a model floating house once you get funded, but how do you want to scale down your design and what is the actual size of your model?
Okay, I have two questions for you. Number one, the idea of floating city was discussed in the past many years and in many fields. The carbon neutral floating office in Rotterdam was officially opened last year. And the first floating city will appear soon in Busan, Korea. So could you please describe the most interesting new features in your presentation, in your design, compared to those announced? Number two, there are about 2.7 million people living in Kaohsiung. If 1% of the population, which is about 27,000 people, will live and work in the floating city in a sustainable way, do you have any idea about the size of the city? How big will the city be how big will the city be in terms of the area? Thank you.
I think the idea is interesting, but I didn't see the timeline and the budget for this proposal. Could you propose it and explain the design of this timeline and budget? The second question, I also wondering where in Taiwan you think is doable for this project. Thank you.
Okay, so about the first part, I would like to answer that when and where should we develop our floating house? We have mentioned that we're going to develop our floating house, well, not around Taiwan, so that we won't face the problem of typhoon and any other weather disasters. Our plan is to develop the floating house in a place that without those weather disasters. And for the next question is for the power source energy problem. We have mentioned in our plan that we will install a water pump underneath the floating house to generate electricity, and it is hopeful that this would help to contain and maintain the power resources on the floating house community. And as for the other questions, my other teammates will help and answer. Thank you.
Okay, so for the question, new features in our design, we have a water desalination plant and also a sea farm planted on in our floating community. And also for the next question, size of the city, we hope that the city will be big enough to have all refugees or most of the refugees able to live in our community. And also for the timeline and budget, for the timeline, we hope that our project will be able to use as soon as possible, because now there's still many refugees. And also for the budget, we're still doing researches on that, and we hope we can use as least as possible.
Okay, just to add some more information about the question of the simulation and the exercise of model we're doing it. So first of all, we students do not have the technology to simulate such a complicated model, but however, we are seeking for chances to cooperate with some professional institute in Taiwan or around the world to help us to do the simulation. And the actual size of model that we're making it, we are hope to be as large as it could accommodate families that we've mentioned in our plan. So the problem we're facing is we're seeking for cooperation to get budgets and to get technology to do this kind of simulation and do those make those models. And as for the comparison to the previous project that I believe you've mentioned that is provided in Korea, I'm afraid that we are not professional enough to do the comparison now, but we will try and do more researches and let our project have a further step possibility and to accomplish. Thank you. And I believe that we have answered most of the questions, and I believe they would be the end of our answer. Thank you.
Thank you to the Team Environmental Recovery Organization for their presentations. Last, please welcome Team Eco Beach from International Bilingual School at Tainan Science Park with their proposal entitled The Effects of Mixed Media Information for Tourists on the Preservation of Coral Reefs.
We are Team Eco Beach, and we're presenting our proposal on mixed media information for the preservation of coral reefs. Taiwan's biodiverse and culturally and economically valuable reefs are getting destroyed by anthropogenic influences such as pollution and tourism. Low levels of engagement and care for the reefs among the people is also worsening this situation. Our primary goals with our proposal will be to educate or spread the awareness of these issues through media.
Our motivations are the following. Firstly, tourism harms the reefs. Trash and other wastes left on the beach or in the reefs can pollute the waters and block sunlight, making survival for the corals harder and lowering biodiversity. Tourists touching the coral can cause unintentional harm to the reefs and the ecosystems around them. There is a potential loss of profit because of depletion of coral by means mentioned above.
So for our second motivation is that we see a lack of conservation, as in the coral restoration efforts by the government were last launched in 1999. So the current conservation and restoration is being carried out by NGOs, not the government. And the importance of coral conservation is not ingrained into most people, as the referendum recently tells us that 48.37 voted for the natural gas terminal instead of preserving outer reefs, which shows they prioritize energy over conservation.
Furthermore, there are the advantages of digital integration. Taiwan is a highly digitalized country, currently ranking 8th in the world as of 2021 for competitive digital economy. Use of digital appliances in everyday life is high and still on the rise for Taiwanese citizens. Our plan will utilize the frequency and use of said digital appliances to spread the environmental awareness through the media and to the people.
Thirdly, corals are disappearing. Between 2008 and 2019, according to the UN, as of 2021, 14% of the world's coral was lost. And around 75% of the world's coral is at risk. An estimated 50% of the world's coral has disappeared since 1950. Furthermore, decreasing Taiwanese marine biodiversity and the loss of large portions of economic profits are going to be permanent if no substantial actions are taken.
Lastly, we see the current education system is lacking, as only 4 hours of environmental education are mandatory for the Taiwanese student curriculum, gives only a rudimentary understanding in environmental literacy. as the lack of emphasis on the importance of both the economic and cultural impacts of landscapes or ecosystems within the environment due to inadequate education on said topic.
Moving on to our objectives. Our first objective is to ensure future tourist maintenance of the Taiwanese marine ecosystems by reducing the amount of environmental damage done by tourists and tourism. Secondly, we wish to raise awareness of the environmental problems in Taiwan's coastal regions, including other major things negatively impacting the coral, such as rising sea temperatures, pollution, and agricultural runoff, by the most accessible, and efficient method of spreading information.
Our third objective is to further promote the goals designed by the Taiwanese environmental education system, which are to achieve international environmental education goals, develop teaching materials on environmental education for classrooms, communities, and the general public, and to develop sustainable solutions for a healthy Taiwan. Our fourth objective is to promote engagement and education of Taiwan's youths on the local environment and species, as these youths are the future of conservation efforts.
Okay, so our next objective, the very last one, is to introduce and promote environmental protection to newer generations by integrating impactful information with the modern technology accessible and preferred by the general population. That is that we integrate important information with entertainment apps.
So our solution will be to create, install, and use infographics speaking against harmful tourist practices on the tourist beaches, and also using QR codes that connect to a website with further information on preserving the local marine life. We also plan to organize campaigns discussing the significance and method of preservation of Taiwan's coral reefs to accompany this plan, collaborating with the media and schools across the country to raise awareness. Through our plan, we hope to improve the preservation of Taiwan's coral reefs.
Why is our solution special and unique? Firstly, almost all of the education campaigns or events are targeted towards adults. For a few examples, see below. Also, we bring in new ideas, which are, there's currently nothing about technological usage or installation of infographics on beaches within the SARS group.
So methodology, so before we move on to the next slide, this plan will be utilized A and before after study to test the effectiveness. So our part one is the web creation. So what will it feature? It will feature firstly cuter designs appealing to youth and the soft spots of adults. Secondly, it will easy to read tabs introducing each local marine species with sample illustration and photos. And we will also put sign-ins with QR codes that lead to the website will be installed at beaches selected for the study. Website information will feature firstly the damage that tourists may cause to species previously mentioned and shown. Secondly, how the tourists, such as individuals themselves, can avoid such damage and further preserve the local biodiversity. And third, other large-scale issues that also strongly impact the species, such as wastewater pollution and harmful fishing practices like ghost fishing.
The second part of our plan will be infographic boards at beaches. The infographic appearance will feature more compact information in the form of colorful and appealing styles to attract viewers, and these will be installed at many major beaches of Taiwan. Information on them will include various tourist practices that negatively impact the local marine life, such as touching coral and how they harm the environment. There will also be information on banned things that tourists should not do. The boards will be promoted through social media such as Instagram, Facebook, and Twitter, and hopefully commercials sponsored by the Taiwanese government. The effectiveness of these boards will be tested with a before and after study as previously stated. At the start of the testing period, 5 beaches will be randomly selected from all of Taiwan's major beaches that feature coral reefs. We will also identify the coral reefs with more tourist activity. We will then record the number of healthy and unhealthy corals and take pictures of them on each beach. After 1 year, we will record the number of healthy corals, compare it to previously collected data, and draw conclusions.
Part 3, campaigns to spread awareness. So we will visit various schools across the country, hosting events with preservation that will educate the students on the declining biodiversity in Taiwan's coastal reefs and why that is important, including activities that engage the internet, such as fun content quizzes on websites like Kahoot or Quizlet, and offer gifts to the winners of the games. Also introducing ways that the people themselves can help environmental preservation efforts. Also promoting the international website and installations at the beaches. Other methods will include media collaborations, as mentioned in the previous slides.
Expected results. So we would compare the data collected at the beginning of the experiment and the data collected after 1 year. So if it shows statistically significant increase in the percentage of healthy or improving coral, a plan will be considered effective, and infographics and QR code bars will then install at all major beaches in Taiwan. We will also pass out surveys to participants of campaign events, and if there's a significant number of positive answers to the questions, campaign will be considered effective, and data will be based on the amount of questions answered correct by the student to infer the effectiveness of our campaign on the youth for part 3. Next on our funding. Yes, our funding. So our expected result for our funding is that first part 1, we don't spend any money. And for part 2, we spent around 16,760 NTD as the median size infographics we will make it as like this presentation. It's free, but the boards is 2 feet times 8 feet, which will be around 838 NTD times 20 beaches, which is the major ones in Taiwan, which will cost around 60,760 NTD. So for part 3, the awards we're going to give to these students will be about 10,000 NT, as we discussed before. So
furthermore, there will be other costs related to factors that we cannot yet determine as we are still making our proposal. Thank you for viewing.
I think as a high school student, you did a great job, but I feel that you have a couple things that you may need to notice. First, you mentioned that you do the integrating impactful information with the modern technologies accessible and preferred by the general population. However, it's difficult for me to find your integration way. Second, you mentioned the 3 things that you are going to do, including website creation, place in depth, infographic both at beaches, and campaign to spread awareness. However, I think for these 3 things, this already implemented recently and continuously. Could you mention more? Could you give us more explanation about your most special parts related to these 3 parts or additional ideas? Thank you.
Yeah, I have 2 minor questions for your proposal. The first one is that, to my understanding, setting the signage at the beach to reach environmental education is quite a very common and easy way. Okay, so and also using the media. Okay, using the media to reach the environmental education program in cooperation with media and the schools is also a very conventional way for the environmental education. So here, I just wonder what would be the unique points or unique characteristics of your program to fulfill the goal of environmental education. I think it's better for you to specify the unique characteristics of your program. That's it. Thank you.
In your proposal, you plan to do site survey to observe the coral in selected 5 beaches. But I wonder if you are trained to do the survey. Are you licensed scuba diver, or are you familiar with coral taxonomies? The second question is, there are a lot of anthropogenic factors that may harm the coral. In your opinion, What are the main threats to coral in Taiwan?
Okay. From my understanding, the making of the website seems an important part of the project. Therefore, I have two questions about the website. Number one, the richness of the website is important to attract people. So high-quality photos are important. How will you legally collect beautiful photos of each local marine species for many major beaches and update the information regularly? Number two, how will you maintain the website after the project is over next year? I believe you just don't want the website to exist for 1 year only. Thank you.
I think the conservation of coral reefs in Taiwan is a very important issue, and I like your proposal. But I'm wondering what's the spatial part? What's the spatial of your website compared to the current available website? So make your website more successful. And what's your timeline and budget to conduct this project? Is any spatial area is your focused area for this project? Thank you.
So one of the judges asked a question about how exactly this method of integration works that we talk about, where we're using both digital resources and in-person resources. And basically the explanation of this method of integration is, as we mentioned, with websites and the QR codes and stuff like that, where we have digital information that also works with in real life information that you see in person, such as infographics and stuff, and like the educational campaigns and stuff like that. So for us, what we mean by method of integration is by having both digital and in-person resources, because digital stuff is kind of integrated into human life already. And so we're taking advantage of that within our plan. Word.
So for the concerning about the question about the judges, the main problem that judges have with our plan is that the uniqueness with a conventional website. So what makes our website so accessible to the public is that often we're focusing on these beaches where there are more tourism activity, which means that it brings more accessibility. And also concerning about how the internet and the QR codes of those and the advertisement this even makes it more accessible, as most of the people have these access to the internet. So what makes our website so appealing to others is that we inform these pictures instead of a bunch of words, which is not the case with current websites. And we add easier content that's easier to state the main problem with the problem with the beach, the coral reefs, and other stuff. So just in general, we're trying to cope with what the societal norm of how people are currently more integrated into globalized internet and trying to use their phones and other stuff. We think that's more accessible to these people compared to these websites, and compared to these websites, we're more appealing, and we have QR codes and to these more accessible to these QR code people who are QR code things that are in these places, in these beaches that are has high tourist activity. Then your turn.
Furthermore, something that also makes our proposal special and unique and different from what we already have right now is that this stuff, like the website and infographics and stuff, are going to be made to be targeted towards tourists and possibly younger audiences, such as, kids. Like families will often take their kids to the beaches and coral reefs and stuff like that. And also, as Edward mentioned, we're seeking to spread awareness much more, which will mean that more people will have access to these things and have an idea of it, especially with the QR codes, which is not the case with current websites or any sort of informational websites or sources that we currently have. Okay, Ben?
Right. To address the problem of being untrained, or the question of whether or not we are trained, we would say that firstly, we are not trained. Therefore, we are hoping to work with professionals on issues pertaining to the examination of the conditions of coral and also photography or actual diving. Yeah.
Yeah. Okay. And then also there's the mention of the main threat to coral in Taiwan. What the judge asked us what we thought about that. We personally believe that the biggest threat to coral in Taiwan is generally things such as overfishing, or like fishing in general, like harmful fishing practices such as trawling and ghost fishing and stuff like that, and tourism, because Taiwan's coral reefs attract a lot of tourists. Though I do have to say, because of coronavirus, there haven't been that many recently, but it's still a problem where tourists who do not exactly know what can harm the coral and what might not, such as accidentally kicking up too much sediment and covering the coral and stuff like that. Those types of things are the greatest harms to coral that we personally believe right now that we can actually do something about. Yeah. And also about the website. There was concerns about whether or not we'd be updating a website after this year is over. And what our answer to that is that, as this is a project we're very passionate about, and we're hoping to continue.
Thank you to the team Eco Beach for their presentation. Ladies and gentlemen, that wraps up our first day event. Our competition will resume tomorrow morning at 9:30. And stay tuned, and I will see you tomorrow.
Our answer to that is that, as this